I haven't practiced my English for a long time. I'm a little nervous.
I wouldn't worry. This is the whole of Europe. They understand the issues that people have with languages. Like the average European speaks 3 times as many languages as the average North American.
Yeah, that's right.
Yeah, you don't have to worry about. I believe most of the people who are joining us today, English is our second language, so it's totally fine. Well, yes. In theory, we can start for this panel. The recording is on my phone. Sadly, our last panelist maybe joined during the event, hopefully, but we need to start. So, hello everyone, and welcome. Oh, somebody is coming. No. Hello everyone, my name is Davor, and I'm going to coordinate this panel as well as the rest of the event. So, welcome to South American panel of our event. And welcome to all of the panelists today. Today with us we have Dr. Felipe Freitas, Jorge, I'm sorry if I'm butchering that, Ramirez Peach, and Professor Lawrence Becker. Please correct me for the pronunciation of your last names. Yes, each panelist can tell us a little bit about themselves, a short introduction. We can do whichever order you wish to present. So whoever wants to go first, you can share your screen or just start talking about yourself.
Let's do it alphabetically.
Okay, then we can do, what is it, Jorge first?
Yes.
No,
Okay.
it's Felipe.
Who is first? Felipe?
I think Felipe.
You are already
Okay.
there. Go ahead, Jorge.
Thank you, Felipe. Okay, I go to share again.
Yes.
The screen. Okay. Wait. Do you see it?
Yeah.
Yes.
Okay. My name is Jorge. I'm a biologist. I studied a master degree, and right now I'm a beekeeper of Melipona bees. So we're going to talk right now about the popularization of native bees. Oh, wait. So why do we need the popularization of native bee and all pollination, not bee? But I got to talk about just bee right now because I don't know everything. Well, that's one of the problems that we have right now. People don't know about native bee in general. Of course, here we know a lot about native bees, but many authorities and people think that helping bees is having more colonies of Apis mellifera. I don't have any problem with Apis mellifera and beekeepers, but who teach you that at the school about native bees? So why are you going to protect or care about something that you don't know? But look at that, for example. It's just one flower, and we have different species of native bee in one flower. They don't know that the people don't know that we have a lot of native bees. Especially solitary bees. And I understand that because, how I told you, who teach you that? So you can see all kind of bees that we have in one flower. So how do we know about the lack of knowledge of native bees? For example, if we use that, for example, page, Google Trends, it's a kind of tool for what the people is looking for. We're going to write 3 words, bee, honey, and melipona. As you can see, the word bee and honey are the most searched. So you can say, oh, good, because people are caring about bees. The problem is that the word bee and honey are related to Apis mellifera. So almost all the information that we have in the internet is about Apis mellifera. Just we have a little of native bees. But you can say, oh, we had a paper about native bees. I mean, all the research we had made are for the people. Right now, it's easy to get a PDF file and you can look for native bee. But we have some problem with that papers or that kind of information. For example, first, the language. Not everybody speak English. For example, for me, it's difficult to talk right now the English. And for example, even if you can read the paper in English, sometimes it's difficult to understand the technical words are sometimes difficult. And people are reading less every day. Another problem that we have is that you have to pay for the information, not for every information, but sometimes you have to pay. And if you see the price, at least in Latin America, is 1 day of salary to get access to 2 days of the paper. I mean, it's difficult to get that information. Yes, we have some web page where you can get the information for free. But the problem is that the people who are looking in that web page or using that paper are specialists of that, for example, here on bees. That information is not looking for the general public. It's just for researchers or people who had some kind of knowledge of native bees. For example, I'll give you one example. When I wrote my first paper or appeared in one paper, I was so happy. I mean, really, I showed that to my mom, my dad, my grandmother. But when I showed the paper, I read it. I mean, my grandma couldn't read English. I mean, my dad, he can read English, but he couldn't understand the paper. So how can they understand that information because they are not a specialist in native bees? So after I showed that in a video, for example, sorry for the sound. When I showed that, for example, with a video, they could understand about the group of bees that I was working, orchid bees, where the male collect fragrances. I tried to bring the female of their species. So it was much easier than instead of the paper. And the same when I try to talk about boost pollination. For example, I can say, read that paper about boost pollination, see how it moves. Read the paper and try to understand that. But when I showed the boost pollination in the video, it was much, much easier how the boost pollination works, and that not all the bees can do it. For example, Apis mellifera can do that. So, for example, it's much easier to explain many things for the general public with this kind of information, photos, and videos. For example, wait. So years ago, I began my web page, and the social media. The main reason was to sell the honey of Melipona. I mean, I'm not a good person, or I want to do just for the bees. I want to maintain my product of Melipona bees. So, but the problem was that many people don't know that we had Melipona bees, stingless bees. So how can you sell the honey of Melipona bees if nobody know about Melipona? So I began that project. I have become what I hate, a kind of influencer. So, but everything for the money and science. So I learn about photo, video, SEO, search engine optimization, web page, all that. That's very different for a biologist. But the good things with all that web page and social media, you can have a lot of information. For example, here we have the age, which country sees you, and a lot of things. But we have one problem right now, for example, is you can see here, people are reading less. So right now, to write a blog or make a paper, it's not working right now because we have really, really a big problem. I mean, TikTok. I mean, for example, people are in their cell phones looking for information in less than 1 minute. So short videos are getting so high right now. But the problem is, how can you explain important things in less than 1 minute? I not tell you that every researcher have to be an influencer, open a social media, or have to make TikTok. I mean, they don't have time, really. But we have to look different way to reach the people, the general public, because if we need to protect native bees, they have to be known. I mean, they have to be known. So that's why, for example, I use social media. I'm a beekeeper. I work with Melipona, and I still work with university. But I can see the paper are not reaching for everybody. I mean, yes, we're reaching for another researchers, but not for everybody. Uh, Thanks for the time. I hope you enjoyed the presentation.
Thank you so much. We have a hand up. If you have, maybe it's different. If you have a question, please write them in the chat. But thank you so much for introduction. And you have really cool videos of bees pollinating and buzz pollinating. Yeah, Felipe, if you want to share your screen and introduction.
Yeah, I'm sharing the screen. Can you guys see it?
Yeah, you can see it.
Okay. I am Felipe Freitas, as Davor introduced me before. I'm currently a postdoctoral researcher at the Universidade de São Paulo here in Brazil. And I'm going to talk a little bit about my research program, which mainly involves bee systematics. So what I mainly do is using phylogenetics or phylogenetic methods, which involves taking molecular or morphological data and use these data to infer evolutionary relationships among different species. I work mainly on bees, so I infer these relationships among different species or groups of bees. And then what we can do with or how we can use this phylogenetic hypothesis, there are many uses for that. One example is this one where we used a phylogenetic hypothesis to support the recognition of a new species that we found here in the Brazilian Atlantic forest. This was a paper we published in 2018. We can also use these phylogenetic hypotheses to guide or to support our classifications. So with that, we can make sure that our classifications, they only recognize what we call monophyletic groups, or groups that include only like all the descendants of a same common ancestor of a given clade. So that's what we did in this paper published in 2023, where we studied the long-horned bees, and we did some adjustments in the classification of the group using this phylogenetic hypothesis that we produced using molecular data. We can also use these hypotheses to study historical biogeography, as we are doing now for the colatids or cellophane bees. And we are now able to say with some level of confidence that colatids they originated and started their diversification in the Eocene, a period when South America, Antarctica, and Australia were still connected. So they were in these three areas at the same time back then in the Eocene, when the planet was much warmer, and Antarctica, at least during the summer, was able to to support life. So we have fossil forests in Antarctica. So we have evidence that this area was able to support a fauna of bees and other organisms too. So we can also use these phylogenetic hypotheses to study, for example, the evolution of morphology, as we've been doing in this project, where we show that the tree can explain also how the morphology of different groups of bees, they change it along or throughout time, and correlate these changes in the morphology with patterns of diversification that we can see reflected in the tree. Here is a tree that we inferred using molecular data showing the rates each group was diversifying throughout time. These things are, at least for me, really exciting. That's it. That's a small sample what I've been doing with bees and phylogenetic methods, and this is my email address if someone wants to reach out.
Thank you. Again, amazing presentation and really cool information. Dr. Lawrence, your mic is off.
There we are. Can you hear me now?
Yep, you can.
All right. I apologize. I don't have a slideshow ready, which means I have to put you off your lunch or dinner because you have to look at me while I give the talk. So I'm Lawrence Packer. I'm a retired professor. I spent my career studying bees, and I'm still doing that. I'm still doing taxonomy in my retirement. So I'm old enough, I can remember when people mentioned that bumblebees were important pollinators, all the agriculturalists would shake their heads and say, you're crazy. I think nowadays everybody understands that bumblebees are important, and here in Canada we get most of our winter vegetables, or certainly what is it? It's cucumbers and tomatoes from bumblebee pollination in subarctic greenhouses. So we know bumblebees are important now. But when I started 50 years ago, people thought that bumblebees weren't important. Now we understand that just about all bees in the world are important. Anyway, so I'm so old, I hope to die before I have to use artificial intelligence. I do have some social media. You know, I've got an Instagram account. You can find me if you Google Bugs R Us. That's BUGSRUS. You'll find all sorts of pictures of bees on my website. I started off as a sociobiologist studying halictids. In the first 20 years of my career, I got most of my data by digging holes in the ground, because these bees nest in the ground and you have to dig them up to find out what they're doing. That got a little tiresome. And so before the beginning of the current millennium, I decided to switch my research to do systematics and taxonomy. So that's what I've been doing for the last 25 years, and what I hope to do for probably not another 25, but maybe 20 if I'm lucky. So one of the things is, if you're interested in conservation or pollination, you have to know what it is that's visiting the flowers. And while it's sometimes possible to identify things based upon the beautiful pictures, when we've seen some of these, usually you need to identify a specimen or a part of a specimen. So if you want to leave your pollinators alive but find out what they are, you can just take a leg or an antenna from one and then let it go again and identify it using DNA barcoding. I've demonstrated that this works in my backyard. Bees that I've removed a leg or an antenna from, I still find flying around a couple of weeks later. So although it sounds a bit gruesome, in fact, doesn't seem to affect the bees too much. So how do we find out what it is we've got? Well, we have to describe species. Well, first of all, we have to find the species, then we have to describe them, and then we have to find out provide ways of identifying them. So in my lab over the last quarter of a century, we've described over 200 new species of bees. There's half a dozen undescribed species in this tray here. As you can see, they're pretty small. It's easier to find undescribed species if they're small. For example, I once visited a museum in northern Argentina where there'd been a bee expert living there for 20 years. And in 2 weeks, I found more species of small bees than he found in a career because he was only looking for the big things. So what I do then these days is to describe new species. I do a little bit of phylogenetic work. I've done a lot of barcoding, and most of my work has been done in Chile, which is why I'm in the South American panel rather than the North American panel, where certainly in Canada, the bees here are less diverse and less interesting to me as a taxonomist than the bees are in South America. So in Chile, I found maybe getting on for 100 new species in a country where there were only 400 or 500 species previously known. So there's an awful lot out there to yet be discovered through new collecting and new study of specimens, and I'll stop now.
Thank you so much for, again, a really good introduction. So yeah, we did have questions planned for the event. I will add some questions during the discussion to moderate it and guide it. I did not know that you can take a leg out of a bee and it will continue to live. We do that with crayfish. They might actually regenerate the leg, I'm not sure, but I know that they do survive, so it's easier for metabarcoding, but this is a very cool data.
Yeah, I'd recommend an antenna rather than the leg. In fact, I'm not so sure how well they do with a leg removed. I made a mistake in real time there. You can remove an antenna and that'll work.
Oh, yeah, still definitely interesting. We did mention hate for honeybees in the beginning of the event. So I'm interested to see, we did have lectures already from the region of South America. Dr. Rosa Vasquez talking about melipon bees, but we kind of just briefly touch upon the Apis mellifera there. So they are invasive species basically everywhere outside of Europe, and they are probably invasive to a point in Europe itself. So how big of a problem do you have with Apis mellifera in entire South America? Whoever wants to go.
Can I be the first?
Yeah, of course.
For example, I mean, I don't have any problem. I don't hate Apis mellifera because thanks to Apis mellifera living that. So the problem is, for example, our governors or when they want to make a project about the conservation of Pollinator, they think that Apis mellifera is the only bee. So all the resource of investigation go to Apis mellifera. So they don't see, or they don't, how can I say, protect the native bees because they are not so famous. That's the problem, for example. That's the one problem that we have here in Latin America. I mean, the lack of famous of the native bees.
Anything to add?
Well, I would add that like we have problems with accidents too. It's kind of frequent, especially for people working outdoors. Like for example, my wife, she works in a consultancy company studying caves. That's why we have some books about caves here in this shelf. And they are frequently out at the field looking for caves and going there to study them. And they have lots of accidents with Apis mellifera in the field. And it's a big source of fear, and also they spend lots of resources with security equipments for people. And I don't know if it's true for other areas, but here they are active all the year. And sometimes when it's warmer, they can get really aggressive. So this is a point. And also there is always the competition with native bees, which is frequently pointed out as a problem for native bees conservation, because sometimes the aggressivity of Apis mellifera collecting resources can exclude the other bees that are not so efficient or so aggressive when they are collecting resources.
Yeah, I think the only thing I'd add is that honeybees also transmit diseases to native bees, and so they're a bit of a problem from that point of view. Although I actually don't know much about data on that in South America. What has been established quite well is other invasive bees, bumblebees, European bumblebees taken to southern South America, have had a very negative impact on the indigenous bumblebees, particularly Bombus delbomi, which is a very large, bright orange. I refer to it as the flying hamster. You know, it's a lovely, big, bright orange bee. And I remember the first time, there's a national park in southern Chile, and the first time I went there, I found Bombus delbomi. It wasn't abundant, but it was there. The second time I went there, there was about one invasive bumblebee queen per square meter. You know, it was absolutely insane. And then the third time I went, this often happens with invasive species, the populations get enormous and then and then they decrease a little bit or quite a lot and become stable. So the third time I went there were still the invasive bumblebees around, but nowhere near as abundant as they had been in the intervening time period. So it's not just it's not just honeybees that us taking them around has caused trouble with. It's also introduced bumblebees.
That is interesting. In Europe, we have problems with Apis mellifera, mostly in the sense of farmers having huge colonies in one place. So 500 hives in one place is obviously a huge ecological damage. But maybe even more the having them on a truck. So they're just going from place to place. They didn't really contribute to that specific location at all. Yeah, we talked about a little bit about genetics and metabarcoding. I'm interested to see, what do you think about environmental DNA methods regarding research of pollinators? I believe that this is a method that's kind of newer right now, and a lot of people are doubting it. So maybe I will be the same as Professor Lawrence in a couple of years, couple of decades, talking about how people didn't believe in environmental DNA, and then in future it will be like the main method of research.
Off the top of my head, I can't think of anything on environmental DNA and bees, but that's not an area that I pay much attention to.
I know that Silas Bossert at Washington State University, he and other collaborators, they are working on environmental DNA on flower petals. Oh, to track which bees are visiting each flower, because we can't be there all the time to see what bees are visiting each flower. So if you can get some DNA from the petals, you will be able to have a better sense of what bees are visiting there. But I haven't heard anything about this project, if it's been a success or no. But it's a really cool idea to use these methods to track the visitors of a given flower.
Yeah. So one of the questions that I had was basically to ask you to compare the pollinator diversity of South America and Europe, but obviously that is a difficult thing to do if you didn't work on the European bees. But maybe go to the question about, so what are the biggest current threats for pollinators in your region? We asked that on every panel just to see the comparison between the continents, and it's interesting so far.
Well, I can actually address the first question that you skipped over, because the collection I've got is global. I'm originally English,
Oh.
And so I knew, and I keep up to date with the European bee taxonomy globally. So there's a lot more species in South America than there is in Europe. Furthermore, in terms of species that we haven't yet described, Tom Wood, who you had on earlier, he's describing new species from Europe, and he's finding surprisingly large number of new species. But every trip I go on to South America, I come back with bees that nobody's ever seen before. So I spent 3 days in the field in Bolivia, and I caught twice as many species of ground nesting Panurgine bees, these are andrenids, than were known from the country. And so in terms of what we know about what bee species are there are far more in South America, and there's several orders of magnitude more undescribed species in South America than in Europe. So sorry, I kind of interrupted you, but so
no, perfect. Thank you for answering that question.
I would like to add something about
sure.
this question too, because this is an interesting question regarding this view that I am more excited to talk about, which is the evolutionary view based on phylogenetic hypothesis. And when we look to what we know about bee evolution, this pattern that Lawrence described, it's not too hard to understand, because bees originated in the first half of the Cretaceous in Western Gondwana, which means when South America and Africa were still connected. And besides that, most of the diversification of most of the families, they took place in South America, because it happened after South America and Africa were separated from each other. So it means that most of the bee lineages that we know, they've been in South America for longer than in any other continent, and many lineages were never able to leave South America. So besides being there for longer, many bee lineages are still occurring only there. So that's why probably have a much bigger diversity than any other continent in the world.
Thank you. Yeah. Anything to add, Jorge?
No, not
okay. So going to the next question about the questions were initially designed for each panel to go from more like bleak topics, depressive topics, to more positive topics by the end. So hopefully everyone will be motivated by the end. But talking about the current problems and threats to pollinators in your region, what would you point out as some threats to bees, pollinators generally, in your area? Where wants to go?
Well, I guess climate change is going to be massive. As Felipe has pointed out, bee diversity is higher in semi-arid areas. It's beginning to look as if it won't, by the end of the century, most of the Amazon will be a semi-arid area. That's not a good thing for a whole bunch of reasons. Because we're going to lose the relatively small proportion of bees that are adapted to living in jungle habitats. In the semi-arid areas of South America, the weather patterns are changing. The wet season is coming later or earlier. It's more intense, or it's absent. So the variance in climatic conditions is going through the roof. And when you think about it, organisms have to adapt. They have to be adapted to the extreme conditions over long evolutionary time frames. And so if things are fairly stable, then you get the individuals that are adapted to unusually cold, unusually wet, or unusually hot and unusually dry conditions, those genotypes are going to become less common. Then when you get an intensely hot and dry period followed by an intensely wet and cold one, you get selection against both, you've got selection coming from both directions. And so I think most organisms are likely to be suffering as a result of climate change, and I would consider that to be the main problem facing bees anywhere.
Yes, Jorge?
As Dr. Lawrence says, yes, we have a problem with climate change because here in the Peninsula Yucatan, we can reach 45 grade Celsius. So it's hot, yes, but for example, 2 years ago, we reached 45 Celsius for 40 days. So we can, how can I say, we can saw a lot of mortality in colonies of Melipona. So almost, I'm sure that 100% of the people who work with Melipona lose some number of Melipona. The same happened with Apis mellifera, who are adapted much better for climate change. But with Melipona, we see a lot of mortality. So how about solitary bees? We don't know. I mean, if social bees are endangered, we don't know what about solitary bees because we don't have information. And the other problem is that deforestation, because people want to help to the native bees or the bees having more bees instead of giving the condition to live. I mean, it's, well, two of the main problems here in my locality. I think in every place.
Yeah, I agree with you, Jorge. We definitely still have a, a big problem with deforestation, and it's true here in Brazil. We still have areas under a big pressure with deforestation, but we also have problem with the irrational use of pesticides. Brazil is probably one of the countries that uses more pesticides in the world, and it's mainly because of the number of monocultures that we have here in many different regions. So we depend on the pesticides to support these huge monocultures of soybeans, corn, cotton, and other things. So I agree with you that climate change is a big threat, but like I think we have others that are more urgent to deal with, like the deforestation and the use of pesticides. I think they are more like urgent to be solved because I think we also have a better sense of how these things are impacting the bees and other pollinators than the climate change that we are starting to have a sense. I think there's a paper that was published last year showing that here in Brazil we will have, with the increasing temperatures, a tendency for species to move a little bit south, which will be interesting because it changes the pressures that they are under. Like they will need to compete with species already occurring more southern. That there is always the problem with the specialists that will need to see if their host plants are also more south. So this is a big source of concern, I think.
Yes, I would agree. In Europe, Europe, I'm from the Balkan region, obviously. So we have a problem that there's a lot of pesticide use still, although my country has been in European Union for some time, but although there's strict laws, they're still using too much pesticides or prohibited pesticides. And the only real way that we can see that is by the huge death of bees. We have a couple of situations now in different parts of the country where honeybees have died out in hundreds of different hives, but we have no idea what's happening in the nature with the wild bees, and it's not like we have some sort of coefficients that we can compare it. We do also lack the data of distribution of wild bees in our region. So I'm wondering, do you have the similar problem with the lack of data? Obviously, you have so much data to collect in general, but is it because there's so much, or because you also lack researchers who will do the collection and determination?
All of the above.
You first, please.
Okay, so the lack of baseline data, like Europe is the best in terms of baseline data because people have been collecting insects there for longer than anywhere else. In North and South America, there are a few kind of classic studies where people did a survey, collected large numbers of specimens, identified them, and did various biodiversity surveys. But the number of localities that have been looked at in this way is very small. The number of types of habitat where this kind of work's been done is very small. Repeating them is kind of important because you've got the baselines and then you can do comparative studies later on. The number of studies where things have been repeated is even smaller. And so we do need, to get better baseline data all over the world. And in order to do that, you do need more taxonomists to be able to do the identifications or pay for DNA barcoding, which doesn't work 100% of the time, but then neither do taxonomists work 100% of the time.
Anything to add? Of course.
For example, we lack of information. We don't have enough students. I mean, I love science, but who want to be a doctor without a job? At least here in Latin America. I don't know, in Europe it's easier, or North America is easier. And for example, when we want to make project, I mean, your project is about Apis mellifera, it's much easier to get the resource. But if you're going to make it for not a famous bee, it's difficult. Right now we have, how can I say, we're getting something good with Melipona bees, so they're getting famous, so we can get at least some money for the project with Melipona bees. But about solitary bees or wild bee are so difficult. I mean, lack of information, lack of student, lack of resource. I mean, life. I mean, it's difficult to get everything that you want.
Yeah, this is true here in Brazil too. I think we lack more funding than people. We've been forming lots of doctors or specialists in the last decades, but we have definitely a lack of funding or at least proper funding for decent projects to produce better data. As Jorge said, like all these are really issues, but like I for me the lack of funding is the big one. We need more money to be able to conduct these projects and obtain good quality data or high quality data.
In Europe, at the moment, we do have some new funding opportunities, mostly because European Union is going towards the more pollinator friendly, but it's basically just about economy of food production, which is also good because they're opening different grants. One problem that they are facing now is the lack of experts, and from my experience, getting an expert or anybody really to determine the species to a level of genus is also, it's hard, but it's acceptable at the moment. There are a couple of different very good keys and books that you can use, but determination to the level of species is very difficult because Europe has multiple languages, and species determination keys are usually on German or French, sometimes on Spanish. So if you don't speak those languages, it is very difficult to Google Translate the key and then also use it, not to mention the descriptions are very, very specific. So I'm wondering, do you have the same problem in South America? You also have multiple languages, so is that a problem?
I mean, in Latin America, not so much because the Spanish. We don't have problem with Portuguese. I think, I don't know. But for example, all the information for can I say are in English. So I mean, maybe I'm not good speaking English, but to read English is not so a big problem. But we don't have so much diversity of language like Europe's. At least we don't have this kind of problem. I don't know if Felipe thinks the same.
Oh, your mic's off.
Yep.
The old literature is sometimes in German or even in Latin, the really old ones.
Wow.
But yeah, but like I agree with you, Hoy. Most of it is in English or Spanish, and we have also important papers in Portuguese uh, with taxonomic keys. Well, I deal a lot with literature in Portuguese because Danuncia Urban, who was the biggest specialist on Eucerin bees, she wrote most of her papers in Portuguese. So I had a kind of an advantage dealing with those papers. But yeah, we don't have, this is not a big issue for us, especially because when things are in Spanish, it's not hard for Portuguese speakers to understand. And I think the inverse is the same. The languages are really like each other. So yeah, and it's not a big issue, the languages, but like think the main issue is the absence of taxonomic reviews for many groups. So here, this is the main impediment. I think we can't, we don't know who are the species. The thing is not how to identify them; it's to know who they are.
Yeah, one issue I'd add is the quality of the identification keys. Anybody can use an identification key if they understand the language and they've got a microscope, and they'll get a name. Whether it's the right name or not depends upon luck as much as anything else. So the quality of identification keys is something that I've actually spent a bit of time looking at, and on average, they're not good. And so one of the things that I have argued for is that we need identification keys where everything is illustrated, so you can actually see what the characteristics are meant to look like when you're identifying them. And most identification keys, if they're illustrated at all, they're illustrated poorly. And so, this is one of the things we need. And then, you could give somebody a fly and a key to the bee genera, and they will put a name on it. Yeah. So in addition to the identification keys that are illustrated, we need to have illustrations of what the organism actually looks like in its entirety. And there again, that's something which people often do not do. And if you're publishing in journals with page charges, who's going to pay an extra $20, $40, $100 to put in large pictures of the species that they're describing?
Yeah.
Yep. One thing that everybody hates, and I'm wondering do you share my hate with that, and that is bureaucracy regarding different permits for research. Do you have the same problems as we do? In Europe, for example, we had certain situations that in this morning we had examples, but I know a couple others where researchers protected either an area or an organism in an area, and then later couldn't go to that area because they didn't have the permit, although they were the one who protected it. So do you share same problems?
Yes. For example, when I was working for the university, you need a special permission. But to get that permission is almost 1 year to wait to get the permission. And sometimes how can I say, the investigation had finished. So we used to go in that place without permission. Even we were the university. So, I mean, something of Mexico, Latin America, I don't know, really. And
Yeah.
sometimes, well, it's part of the bureaucracy, really. I mean, I want to work on the field or work it at the labs, but sometimes you spend more time in paperwork sometimes. I mean, for permission.
Yeah, the permits are a big problem for us here too, especially if you want to collect in national parks or protected areas. It's always a pain to get permits. and there's other limitation that like it's only for researchers based in Brazil. So if you are from abroad, you can't get a permit to collect here. I think it's true for most countries here. Is that true in Mexico too, Jorge?
Again, please. Again.
Like, do you can like non-Mexican researchers get permits to collect in Mexico?
Yes, you can get it. You put that at the beginning. At the beginning, you can say as people who are working for the university, they can collect. But if you go without the permission, you can have the problem. But you don't need to worry because we don't have enough money to, how can I say, uh, care about all the how can I say the wild area. So it's difficult that somebody, oh, you are taken without a permission. I mean, there is not enough people who to look for every place, really.
Yeah.
Well,
I know
you
it's
Yeah.
not right, but it's what we have.
it's good to be able to ignore the permits, but I think the consequences of getting caught, I don't think any of us want to spend a time in a South American jail, not even a Canadian jail. But one thing I point out, there are some parts of Argentina where even people at the local university cannot legally collect in their equivalent of province, because to get so they need a federal permit, and for the federal permit they need the state or the provincial permit, and there's nobody in some states there to be able to issue those permits, right? There's nobody whose job it is to do that. And so in some parts of Argentina, researchers have to go to other parts of the country to be able to do field work. So, for example, as a foreigner, I went to Bolivia, I collected some bees, they sent them to me, they arrived 12 months later, and I can borrow them. I have to send them back. I have permits to work in Peru. I'm allowed to keep 50 specimens. This causes some issues for doing the field work. At the moment, as a result of Elon Musk's trashing the US government at bureaucracy, it is not possible to legally send specimens to the US, take specimens into the US, or send them out of the US, or take them out of the US. So I've got, behind me, I've got hundreds of specimens from the American Museum of Natural History. I want to send them back. I can't.
Wow.
Yes,
Yeah.
Very interesting.
We're going to get more cheerful soon, aren't we?
Hopefully. Yeah, we do have for the North American panel, we also had lecturers who pointed out that they cannot answer some of the questions that I wrote regarding the policy. Policy of pesticides, different state versus federal laws regarding pollination. So that was a new experience for me, that you cannot necessarily publicly say that you're against pesticides or something like that. But yeah, very, very interesting. But moving on to, because you have experience working in these tropical environments, what challenges do researchers face when conducting pollinator studies in rainforest regions?
Can I say one experience? For example, we were in the forest looking for plants in that moment, not for bee. And for example, we're looking for one marijuana field in the middle of the jungle. So it's one of the problems that we can find. I mean, some of my friends had been kidnapped because narco traffic. So it's some of the problems that we have sometimes in Latin America. And for example, one of my friends, a girl, he used to cut his hair like a man because it's dangerous to be alone as a girl. I'm not saying that they are not capable. I mean, they're good, but it's dangerous to be alone, especially you are a woman making research in the middle of the forest, all that stuff. I don't know, it's happening in Europe or another place.
Yeah, definitely violence is a thing for us, especially if you are a woman. That's why I I I always tell people to not go to the field alone or in smaller groups. It's mainly because of safety. I think this is always the main threat, and also access, right? I think these areas generally have problems with roads and ways to get to certain places. That's why there are studies showing that our sampling effort is extremely concentrated around roads and rivers because that's where you can navigate or drive easier, and it's always hard to go to the more remote places. So I think these two are the main issues I can remember now from the top of my head: safety and mobility. I don't know if mobility is the best word for that.
Yeah, I guess in rainforests you'd have to worry about diseases also. I do my field work in deserts, and in the arid parts of the Atacama Desert, there are no people for large parts of the large areas, and so I put a tent out in the middle of nowhere, and nobody's ever bothered me. I can go several days without seeing anybody that's not actually in another car. And also another advantage of working in deserts is that there aren't many mosquitoes, and so disease transmission is less of a problem.
Yeah, you don't need to be worried about malaria, right?
No. Or dengue, or
Yes.
leishmaniasis.
Yeah, that's true.
Yeah, we have dengue, Zika, chikungunya, and many mosquitoes disease.
Yeah, you want to collect the whole set.
I have got two, dengue and Zika. So
Oh,
terrible, really.
Yeah, well, it's interesting. We have the opportunity to talk about melipon bees. That's something that we have nothing similar in Europe to that. The only honey-producing bee is the Apis mellifera. So I'm interested about just the general rearing of this bee. I mean, I saw a couple of YouTube videos, and it's quite interesting. It's kind of similar. You don't have the frames as you would with Apis mellifera, but you have like rearing boxes. I'm interested to hear about the pathogens or the parasites really on them. Do they have similar pathogens like Apis? Are they do they have the same amount of problem as Apis? Varroa is one of the hugest problem in honeybee rearing in Europe. I don't think at the moment we have real significant problems with other pathogens that I know that North America has, like I think total hive collapse, something like that is called. So could you tell us more about that?
Yes, we have disease, but for example, one of the main problems that we have is the mosquito aphorido. It's the most famous, but for example, we have problem with bacteria, fungi, and many disease that has been described. I mean, some of the people say, melipona doesn't get sickness or they don't have disease. I mean, they are not described. I mean, we don't have enough books or paper to describe all the disease. It's not that we don't have, because the stingless bees are getting famous. So many people want it because they are easy to get, and the price of the honey is so high. So they are moving colonies of different species to different areas. So what can I be? We can have one problem because we are moving diseases to different areas. So, for example, Melipona vechi is one of the species that I used to work. We have different kind of population, the same species, but different kind of population. So maybe somebody can move one bee from one population to another one and spread a disease. And another problem that we have right now is that we're getting disease from Apis mellifera. For example, we have found a virus wing in Melipona, Autina tumida, the beetle of the hive. We have got that in Melipona boxes too. Um, and maybe some kind of bacteria, but we are not sure because we because the lack of research that we have, lack of money, lack of researchers, so and time too is. But we have some problem. And another thing, for example, that happen right now is that, as I told you, many people want Melipona bees, so they're moving Melipona from place who doesn't have Melipona bees. For example, with the social media, I have got mails from, I'm from United States. I want Melipona bees. Can you send me that? No way. I mean, how am I going to send that for DHL? I mean, Amazon, all that stuff. Or for example, people from Spain too. Or I remember one guy from, I think one from Portugal too. So they want to cross Apis mellifera with Melipona because they will get the honey, the amount of honey without a stink. So no way, it doesn't work in that way. But that's the problem of lack of information. I mean, maybe they want to do something good, but they don't know about the disease, the problems that we have, or they can make big problem with that because the lack of information. Sorry, and in Brazil, they have a big problem because many people, because Mercado Libre, Marketplace, they are sharing different species of Melipona, like Pokemon. I want to have this species. I don't have this one. So send me that to me. So they're moving the species to different areas. I mean, because I read the paper about that. I don't know if it's true or is how is
Yeah,
in
it
Brazil.
is a big problem here. They are always like offering and selling colonies, uh, and it was showing a paper on Jataí bees in Tetragonisca angustula that like an haplotype from southern Brazil was found in the northeastern, like in the wild. It was not a bee from a someone hearing them. It was in the wild, so they were not only moving the colonies from different to different areas, but these colonies are escaping. So this is a big issue here. Definitely, you can find people selling colonies easily everywhere in the internet, and there are lots of species. Like we have 300 species of stingless bees in Brazil. At least 100 of them are used for meliponiculture.
It's something that maybe people in Europe don't know. Stingless bee honey is absolutely delicious. Now, compared to most honeybee honey, most stingless bee honey is absolutely fabulous. It's like comparing, an expensive bottle of wine and a bottle of plonk. I know, wine is a big thing in Europe, and so you'll understand that. Yeah, you really don't want to worry about. Sorry, I'm having trouble with my. Can you hear me? Okay?
Yeah, we are hearing you. So the honey from this species I just mentioned, Jataí, it's delicious. It is more acid and more liquid than the honey from Apis mellifera, and it's great. And the bees are not aggressive. They don't only don't have sting, they are docile. Like you can open their box and they will not like attack you. It's amazing.
Yes, with the honeybees, with the apis at least, um, there was a research paper I think a couple of years back that talk about how the more aggressive the hive is, the more they clean themselves, they're less prone to varroa mites. But also, most beekeepers select the queens who are docile, who will produce a lot of workers. The hive will produce a lot of money, well, money, yeah, honey and money. But on the end of the day, if they don't really clean themselves, the whole production thing doesn't really matter. You have to apply more chemicals to them. You have to watch them more. But yeah, the more aggressive ones it's hard to deal with. Yeah, you mentioned the number of species. I think Croatia has around, the number was 750 wild bee species, from which there are like 50 bumblebees. But at the moment, not a single one of them are protected. I think we have protected butterflies, and the syrphids are not protected at all. So I'm wondering about the policy in your countries. Are they how are the conservation laws effective in enforcing the pollination, protecting the pollination diversity, or are they lacking like in Europe?
I mean, we have the law to protect the pollination in general, but one thing is to have the law, and one thing is to apply the law. So it doesn't matter if you have the law, but you can do everything. I mean, because the law is not applied. But it's in general, not in a specific, for example, bee or species, because we have some kind of paper of protecting pollination in general.
Yeah, here in Brazil, we have a couple of bee species in our list of threatened species. It's like our head list, specific for Brazil. We have a few species included, bee species, but I agree with Jorge about that. Like, there are not too many practical policies about conserving these species. They are listed as threatened, but it's basically just that.
Yeah, I served on the committee that lists species as being endangered, the Committee on the Status of Endangered Wildlife in Canada. And while I was on that committee, we listed the first couple of bee species for Canada. And the only reason they were listed is because I was on the committee and suggested that these are things that we need to look at. It is a bureaucratic process. And, you know, once a species is listed, it doesn't really have a great deal of effect unless there are people interested in maintaining the habitat. So, you know, for bees, most of the time, we don't really have a good understanding of what the critical habitats are. There are certain, you know, geographic areas or, you know, habitats or food plants where the two endangered species that were first listed occur. But in general, it's pretty difficult to come up with proper management protocols. And the first species that we listed, the rusty-patched bumblebee, was actually no longer found in Canada by the time it was listed as endangered. So, you know, that's too late.
And just following on that, do you have experience working with local communities, maybe specifically farmers, and how do you approach them? I had some opportunity to work with farmers, to give a couple of lectures, mostly small level farmers, local farmers, not big corporations. And the most effective way that I approach them, at least I think it was effective, is to talk from economical standpoint, basically telling them if you conserve pollinators, you will get more product, more money, etc. So do you have similar experience, or do you have any other approaches that you used?
Yes, I have been working for a community for 20 years. I think the best way to talk with the people is about economic. I mean, of course, they care about the environment, but when you can tell that you will get some money, especially, for example, I mean, I'm working with beekeepers too, but I think that beekeeper is one of the less dangerous work. I mean, they don't destroy so much jungle or something like that. But when you are conserving the forest, you are conserving for all the bees, all that. So if you keep that forest here, you can get money for the honey, all that stuff, and you keep diversity of the species. But is you going to talk, because many people romanticize that, oh, the people of the small town, they live all together in peace, I mean, love, peace, don't care about the money, all that stuff. That is just in fairy tales. I mean, but in reality, we need to reach, I mean, to talk about the economic project. For example, sometimes we have project with melipona bees. The government give the melipona boxes or melipona hives to the people, but they don't see, I mean, at the future, for example, how they will get the market to sell that honey. So after they get the hives for melipona, they, okay, I give you the hives, so that's your problem. So after some months or years, the melipona hives are getting lost or selling because they couldn't find a market for that honey. And especially you are in the middle of nowhere, how are you going to find a good market? So we need, when we make the project, we need to look for the, how can I say, the economic thing too, a market or something to return that money to, because people have to buy food too.
Yeah, I don't have too much experience with that. I'm more like a lab person working on collections and extractions of DNA. So I haven't spent too much time out on the field.
Yeah, and I work in deserts, and one definition of deserts is that agriculture fails most years. So
I think it's
Yes,
good. Sometimes
Felipe.
people is, sorry.
No, yeah, of course. Yeah, Felipe told me that he works mostly with phylogenetics and biogeography, so I try to kind of incorporate the questions. There is one question, so I'm not sure did they even get the topic right, but how can evolutionary data inform modern conservation strategies? In the sense, could you use that data to sort of guide the conservation policies? Obviously, the bureaucracy actually does its job and if politician cares, but could you guide them for most effective way to conserve them, the pollinators? Your mic.
Yeah, yeah. There is one thing that generally we discuss when talking about these possibilities of using evolutionary data to to assist in these decisions about conservation. And there is one thing interesting, which is like we can think about like areas housing higher number of lineages as like more well, let me start again. I think we can prioritize these areas housing more lineages because you will have the chance to preserve like a variety, a bigger variety of the diversity produced during time, right? Like instead of focusing only on of number of species in an area, when you think about areas that you want to conserve, this is a point that is important to have in mind, like because some lineages they have less species or they have like strict distributions and that's why it's one of the reasons why it's important to have a better sense of of who are the lineages or which species compose its lineages, because you can also think about like the better areas to be conserved maybe are those housing more lineages. I think this is the more obvious way to use this kind of data to help like deciding about conservation. That's what I think about this, but I don't know if people have been using it in fact.
yeah, and another way in which the phylogenetic approach helps is that based on knowing where the bee fits in the evolutionary tree, you can predict a lot about its ecology. So, for example, if you know that you've got an andrenid, then you know it nests in the ground, and you know it's solitary unless it's a few species of andrena, or some groups of panagynes where you get a lot of females sharing the same nest. So in general, the only bees that it's difficult to predict the nest site of, once you know what it is in the megachilids, where there's a lot of variation even within subgenera. But in general, you can, knowing where the bee fits in the phylogeny is useful to predict its ecology. And obviously you need to know something about its ecology. Even if it's not been studied, you can kind of guess what it's likely to be doing, based upon where it fits in the evolutionary tree.
Yeah, that's how we should have our classifications based on our phylogenetic hypothesis, right? That, like, to increase our power of making inferences based on the classification. So if these are in the same genera or in the same tribe, they should share more traits with each other than with other groups. So definitely this is a main point. I agree with you, Lawrence.
Good.
This was one of the questions that I wanted to ask, but we already mentioned climate change. So and we did mention it also in today's event earlier, I think, in the European panel. The question is, could climate change disrupt long-standing evolutionary relationship between plants and pollinators? And I do believe that maybe it was Thomas Woods or somebody else commented that they don't really believe that climate change will have that big of an effect on pollination, in a sense that even the generalists, they will still pollinate the same plants if it's possible. But where are you standing on this topic?
Well, I guess the issue is that most plants do not require a specific pollinator, whereas quite a lot of pollinators require a specific plant. So from the point of view of pollination, climate change may not have such a massive effect. But from the point of view of the pollinators, it's still likely to have some kind of impact. There was a data set I saw a long time ago, which I'm not sure it's been published. It came out of Europe, where it looked at the days of the year starting from January 1st, where I think it was red currants. I think it was it was a small scale agricultural crop, and a particular pollinator of that crop were active. And it showed that in the 1970s, 1980s, they were coming out at the same time. But by 2005 or whatever, there was a disjunction between when the bees and when the plants were active. But in that case, both the bee and the plant had other relationships that they could go to be able to persist. So I think that the bees that are going to be in trouble with this are going to be the specialists that require only one or a couple of closely related plants to survive. But in general, the plants are going to be okay. All other things considered equal, which of course they never are.
Yeah, that's exactly what I thought when you made this question. I think the exception would be only those plants that also require like specific kinds of pollination, or that have specific pollinators, which are like only a few exceptions. It's definitely not the rule. So pollination would not be too affected, but the pollinators would be probably affected.
Yeah, I had an opportunity to have an internship in Belgium in the Denis Mishez lab, and we worked on Valpoche is the project. So one of the things that they're working on is seeing which crop plant flowers at what time, which bees fly at that time, and also trying to find the literature to actually have the confirmation that these bees pollinate those crops. And what they found so far is that most of the crops are pollinated by some different bees, but the point is that we know that all of those crops are exposed to huge amounts of pesticides, so a lot of bees would actually pollinate those crops or be in their nearby vicinity and be affected by those pesticides. So it's the plants are will survive, but the pollinator itself is always in some sort of trouble with that.
Yeah.
Continuing on that topic, what is the stage of what's the use of pesticides? How big of a problem are pesticides in your countries?
I mean, for example, with Melipona honey, I have got mortality, and we don't know how the pesticides work with native bees. For example, one of my friends worked with pesticides who are good for Apis mellifera. He tried with two species of Meliponinis, Melipona and Nanotrigona. So maybe it wasn't bad for Apis mellifera, but we have found that it's not good for Meliponini. So we have lack information because maybe you can say that pesticide is good for bees, but when how can I say the label says good for bee, it means just for Apis mellifera, not for all the wild bees. For example, as we have problem with dengue, malaria, Zika, chikungunya, we use pesticides to control the mosquitoes. But one of the problems that we have is when they use that, it affects to the bees too. Because I have that problem in the community where I work. I mean, when they want to control that, because people were dying because of the dengue, so they use that, and you can say, please don't control the mosquitoes because they're going to kill the bees. Yes, but if we don't control the mosquitoes, people will die. So it's a kind of, oh, what can you do? I mean, because people say, oh no, we have to save the bees. Yes, but people are dying. So what option do we have for that? It's something that is difficult to find option, or it's not something good or bad. I don't have the answer really for some problems.
Yeah, Brazil has like a big problem with pesticides. I think we are frequently in the list of countries that use the highest amounts of pesticides every year, and this was also one of the the, the points that like people complaining about this agreement, Europe and South and Mercosur. Are this agreement they are reaching. This is one of the complaints that like the laws here for pesticides used are not so strict as they are in Europe. So that's one of the points that makes our agriculture more or less expensive because we use more and with less restrictions. And I think we are starting to study the effects of some pesticides to native bees, but as Jorge said, like we are just starting to understand it now, how they affect other species other than Apis mellifera. But like I think we are at the beginning yet of having a better sense of how most of these pesticides are affecting our native species. I think it is true mainly for social species, for Apis mellifera and for Meliponites. For solitary bees, we know almost nothing about how they are impacted by these pesticides. But yeah, here it's definitely a big issue for us.
One of the problems is the way pesticides are assessed as to whether they're safe to use or not. What people do is they calculate a dose that kills, LD50, the dose that kills 50% of the organisms. Well, you can make a population extinct by sterilizing everybody in that population. Everybody's still alive. The lethal dose 50 might be infinite, but if they're all incapable of reproducing, then that's no good. I pointed this out to one of the regulators, you know, on the panel doing this kind of stuff quite a long time ago here in Canada, and you know they look shocked. Oh, never thought of that.
I mean,
Yes.
for example, as Felipe said, for example, we have data from Apis mellifera and Meliponines because they are social. So it's easy to get a hype, to see the results, and to get a lot of number of workers with to make the control, all that stuff. But as he said, what about the solitary bees? I mean, especially because the solitary bee do all the job. I mean, collect the pollen, nectar, build all the nest, and in social species they share the work. So it's not the same how the pesticide work with solitary and social bee. But we don't know because the lack of information. Because many people ask me why you don't do that with solitary bees. Because if we don't know the biologies of the solitary bees, we can make a big data of population really, because sometimes it's difficult to find a solitary bees. I mean, how you can get the result of pesticides with solitary bees? So not enough data, and it's because it's difficult, really.
Yeah.
Definitely. I was also part of for a short time of a project that aims at finding protocols for rearing different types of solitary bees, general wild bees, which is quite difficult. With bumblebees, you can do it, obviously. Solitary bees like Osmia, Megahila, also you can do it with the bee hotels, but anything ground nesting is almost impossible to make them nest in some sort of bucket of soil. And not to mention the potential that they have in general, where if you can rear them, you can have more samples, you can do many different things. Bee venom is one of the things that is growing in research for different types of things, multiple sclerosis, different types of cancer, and that's just for Apis mellifera. We have no idea about the venom of other bees. There were some research on Xylocopenia, but very little. I do have a question regarding for specifically for Felipe. I wrote this question, but I'm not sure if you can answer, although if it's even a question that has sense. But if you could map the evolutionary future of pollinators in South America, what trends might concern you the most? And not really concern you, but what trends do you think you can see?
That's a hard question to answer, but I think we are still trying to have a better sense of how the climate change will affect the pollinators, as we've been saying, and I think as I said before, this paper was published I think it was last year, showing the results of niche modeling, showing how the increase of the temperature will affect the distribution of certain species of bees in southern Brazil. And probably the biggest impact that we will see will be these shifts in the distribution. Some species will probably, or at least most of the species will probably change their distributions more to south because of the limits of the temperature they can survive will probably get too high in the northern latitudes. But as Lawrence said before, we will probably have a reduction of some forested areas, and they will probably become more semi-arid or arid areas, which are more suitable for bees. So we will probably have lots of changing in how species are distributed in South America, but we don't have too many projections of how this will happen. So this is definitely a nice field for more research to do projections on how these changes in our planet will affect the distribution of species, and also see how the host plants will be affected. So we will have also a chance to see if they will be affected in similar ways, or they will move to, or they will be under this pressure to move to different areas, and this will make them be at the same place at the same time. So it's I think this is a good field for future research. We definitely can learn a lot with this kind of projection for future, but I don't know too much about it to have a more comprehensive answer.
As things warm up, organisms can move south in the southern hemisphere, northern hemisphere, but they can also move uphill to maintain their climatic envelope. That's less likely in Brazil, which is relatively flat, but in most South American in most South American countries, organisms have got the ability to move uphill over relatively short distances compared to the distances that need to be moved to maintain a climatic envelope in flat areas by moving south.
Yeah, that's the other interesting point about it too. But we definitely can learn a lot making these projections for future. We have some climatic data showing how things would behave in future, so we can use that to project how this will affect some species of bees, as these guys did last year.
I'm interested to see what are some emerging trends, tools, or even methods that excite you most about the future of pollinator research. So it can be AI, but it can be anything else.
Well, I would say what have been exciting me more is something that we already are doing, which is the use of museum specimens to get molecular data. This is something that we've been doing for the last 9 or 10 years, and it's something that like brought a big change for our field, like being able to use the specimens that we already have as a source for molecular data has been allowing us to produce really comprehensive phylogenetic hypotheses and making much broader inferences and much broader studies. So I think it is getting cheaper, so it excites me a lot, and also this possibility of not depending on going to the field to get fresh specimens to obtain DNA. This is, well, I've been working on that. This has been my field of studies because it started exactly when I was starting my PhD. So this is definitely what calls more of my attention. Do you have something else, Lawrence, that you can remember that like is exciting?
Yeah, I think for pollination research in particular, I think the technology of putting little cameras out so that you can actually take photographs of pollinators visiting flowers, it's incredibly time consuming to get those observations as a human being, but you can put out dozens of little cameras attached with flowers. Then you need to be able to identify the bee from the picture, or based upon the environmental DNA thing. But so I think the combination of those two methods is quite promising.
And just following up on the methods that you use, in Europe we mostly use hand entomological nets. We use the pen traps, the colorful traps that attract pollinators. We do have some people using the more advanced traps, not really traps, the picture traps, the picture the cameras. And obviously for night moths, we do use UV traps, but we don't have the opportunity to use any other traps like tree net traps or even Malaise trap are not really something that is commonly used. So I'm wondering, do you use any of those? Do you use any other methods that are specific for your area?
I've used Malaise. Well, I've received specimens from Malaise trap samples a lot. The problem with those is that for every liter of insects, you might get 2 dozen bees, and so there's a lot of time spent sorting out, extracting the bees from the sample from the bug soup. I think that there's a bit of I use pan traps in the desert. I leave them out for weeks at a time. With propylene glycol in them, which evaporates very slowly. And so, I found a new genus based upon a trap with propylene glycol that I'd left out in the field for 6 weeks. These do not work in jungles where it rains all the time. And so one of the things I'd like that's potentially interesting and useful would be to try and design a pan trap with a roof so that the rain doesn't get in. But that's a problem. But Malaise traps can catch a lot of really interesting things, but it's time consuming to sort through. They're also pretty good for bees that fly when there's little light, because those bees have trouble seeing the Malaise trap, and so they're going to get in there more disproportionately more often. We've found new species of crepuscular bees in Malaise traps.
There are also the traps that use stands as baits.
Right.
They are mainly for euglosine bees, the orchid bees, because the males are attracted by a few essences. So we use it a lot for environmental studies here in Brazil because these species are easy to capture, so you can have a good sense of the environmental quality depending on what species you capture. So they are frequently used here, and you can produce these traps by yourself using like those soda bottles. You can just keep a ball of cotton inside with the essence and 2 funnels, one in each side, so the bee can get in, but getting out is harder. So we use that a lot here to capture the euglosine bees, and sometimes it attracts the crepuscular bees too. It's interesting when you leave them out during the night. Sometimes you can catch some Halictus, those well, what is the name of the genus?
Megalopta.
Megalopta, exactly this one. I got some once or twice in the field in these traps.
And one more, multiple questions more, but questions. So the question that I asked for any panel so far is, what kind of international collaboration do you think are most needed in the next decade, and where should the global pollinator research priorities be focused by 2030? I know it's a big question, but yeah.
Well, there are some parts of the world where our knowledge of pollinators is almost non-existent, and so Brazil is relatively, amongst South American countries, Brazil is pretty well studied. There are some where there's almost no serious collecting being done. Bolivia, Paraguay, there's a little in Ecuador, there's some in Peru, there's a fair bit of interest in Colombia. Argentina is, they've got their own problems, which they've caused themselves. In the Guyanas, there's almost nothing. So I think getting a continent-wide monitoring programs, taxonomic tools, courses on the identification of local bees, these are all things that I think are going to be very important for the future.
Yeah, I couldn't agree more. We need more collaboration to make sampling in these areas easier, and because sometimes these countries don't have resources to make it possible. Sometimes they don't have like the taxonomists to identify the bees. So I think joint effort is the easiest way to solve these issues. So we can have funding for someone, the taxonomies from somewhere else. So definitely this is something that we need more.
Yes, I agree with Felipe Lauros because, for example, right now I'm working with one university of Belgium. I mean, we're collecting the data here, the example, but we don't have the equipment to make the, how can I say, the genetic studies. So they have to take all the examples to that university. So we need to complement it to each other right now.
Yeah.
I second all of those. And here's a question that we started asking on one of the events before, and all the panelists love the question. So if you could design one dream research project with no funding limits at all, what would it be?
Oh, I got the bigger fears. I mean, if we don't have any limit of money, I will buy all the cameras, photograph, video, try to find all the species of Meliponids in my country and in the world. Maybe it's going to be impossible. For example, to visit to each one to see what they are doing and try to explain that for the general public, all the stuff. I mean, because it's interesting, but I mean, I want to that all your working or what you're working to get now for all the people in general. But I mean, it will be good, really, really. I mean, to get all that new equipment for Sony cameras will be great. I mean, and no money to travel to visit all the place. Really, will be great.
I'd want to run traps all over the world, employ local people to process the samples, to pick out the bees. I'd like to do taxonomy on them and then send the specimens to Felipe to do the genetic, phylogenetic work.
Yeah, I would do kind of the same. I was thinking in something urgent, which is collecting all the bees in places that are under threat, like every kind of biome that is closer to be like extinct, or those places facing conflicts, wars. I would love to go to these places and collect the bees as soon as possible before they get extinct, and then sequence their genomes, because this is the kind of information that like we can maybe use at some point to recreate them if they get extinct. I don't know, but like having complete genomes for species under threat would be my priority, and collecting all the bees in these places that like we are uh, about to lose. I don't know, like we have many of these places everywhere. I think like here in our Atlantic forests, we have like less than 10% of the original area left. So we need to go out there and find all the bees before they get extinct. So I would prioritize this kind of field work, definitely.
Yes, it's always interesting to see what researchers will do if you give them unlimited funding, and it's also very broad and great ideas.
What kind of answers did you get from the Europeans?
Yeah, good comparison. Well, most of them agree that what they need is research that includes monitoring for multiple years. So more than 5 years of monitoring on certain locations or just the entire country, because it's unlimited funding. That they're lacking in that sense. Also, maybe larger databases and just better interconnectivity between the researchers. I think they all agree that Europe is quite connected, but it can always be more connected, and to have funding not just for the research itself, but also for the people who are working that research. We are lacking taxonomists, we are lacking field biologists. Nobody will do it for free, obviously. Nobody's usually expected. So just to have a large enough group of people to send to the field to collect the samples, and then having them being trained to actually determine the sample is, moving forward, one question, and it can be our last question for this panel. We are slowly coming to an end. What message would you share with young scientists passionate about pollinator protection and research?
Well, something that I always say with younger biologists interested in this biodiversity thing that we generally do is that like there are not too much glamour or prestige in what we do. There are not too much money involved in what we do, but there is a lot of fun in what we do. So if you are interested in having fun, this is a nice field to work. But if you are more concerned about having prestige or lots of money, this is definitely something. This is definitely not something for you. But I think Lawrence is definitely the best person to talk about it. He has much more experience to share with young people.
Your mic is off.
It's still off.
It's still off.
We can't hear you, Lawrence.
We can hear you.
Okay.
Here
sorry.
we go.
Yeah.
I'm demonstrating that I'm really old by failing to use the microphone properly. As you know, for somebody my age, you are all young. So what would I suggest to you all? One of the interesting things I think that you can encourage young people with is to say, you too can find a species that nobody has ever seen before. Now, how cool is that? And so, you know, there's the opportunity, particularly in less well-studied parts of the world, for people to find things that are really exciting. And then if you collaborate with a taxonomist or become a taxonomist, you describe that species and your name is associated with that for as long as there are people. And so, you know, that's the only form of immortality I can think of that might actually work.
That and AI. Yep, continue.
I mean, I agree with Felipe, Laurens. I mean, for example, I will say to young people that, okay, realistic is difficult to get a job in a university. It's so hard. I know so many friends who have a PhD who are not working in what they study. I mean, it's very smart people, but they have to know the reality. But one thing that I really love, for example, is that we're going to die, but we are going to, how can I say, lead something that is going to be, how can I say, take more time than you. I mean, for example, all the data, all the information. For example, 4 years ago, I got the cover for one magazine when one of my picture. I was so happy. I mean, it's going to, I mean, it's going to be forever. I mean, I'm going to die, but that cover is going to be forever. I mean, something good, something bad, but you have to ready for everything.
Yeah, all of those are very nice sentiments about this conservation. Yeah, I mean, as a young person, I think generally, if you are going to start in this area as generally in science, you really need to have love for this. It can be very rewarding, but there's obviously financial problems. There's just the PhD itself. It's internationally this difficult thing to achieve, conquer. And I mean, it's almost a stereotype already to do a PhD and be happy is like a meme also. But yes, I think it can be very rewarding. It can be very interesting. And if you're really following upon the general idea of wanting to work with, work in science, but in this case, working with pollinators, yeah, not sure where I'm going with this sentiment, but it can be very rewarding.
It's a lot of fun, and pollinators and the flowers they pollinate are beautiful. So I stress the aesthetic advantages of being a pollinator biologist. Bees are beautiful, flowers are beautiful, science is fun. You got everything covered, pretty much.
I would agree totally. Well, we came to the end of our questions and end of the South American block. Thank you so much for being panelists on this blog, being panelists of this event, and contributing with your knowledge, your perspective, and the general ideas that you brought here. Yeah, thank you so much. Also thank you to all of the participants that listened. And hopefully all of you will stay for our next block, which is the North American block. I can see that all over the panelists for that block are already here. I can see Dr. Eleanor, and I think everybody is here.
Thanks a lot, Davor. Nice to meet you, Jorge, and good to see you again, Felipe. Thanks a lot for the invitation.
Yeah, thank you so much.
Thanks for the invitation.
Thank
It
you.
was a pleasure to join you guys.
Thank you for
I think
coming.
it was a pleasure. See you.
Right, so we can continue. For all the North American panelists, if you can just check in for your mics and your cameras if you want to have them on. Hi, everybody.
Hello.
Hello.
So my name is Daur. We communicated or email. Thank you so much for joining us and being part of the North American panel. If obviously you can in your introduction you can have 5 minutes. You can use a presentation. You can just talk without anything. If you do have a presentation, I would just ask you to try sharing your screen one at a time, just to check if everything works on the technical side. We had some problems in the morning, so whoever wants to go first.
I have slides.
Mhm.
Let's see. I have to change some settings.
Okay. During that time, can Crystal or Dr. Gale try sharing?
I don't have slides.
Perfect. No, that's fine, totally.
So, hello, my name is Gail Ingalato, and I'm a professor of horticulture at Oregon State University. I lead the Garden Ecology Lab at Oregon State University, where our research is really focused on garden systems, the biodiversity that garden systems can host, what makes healthy soils in garden systems, and also how the decisions that gardeners are making with plant choice as well as garden management influence biodiversity. I'm an entomologist by training, having received a Master's of Science and a PhD in entomology from the University of Maryland with a focus on insect ecology. So most of our biodiversity studies in garden systems are focused on insects, and I have a long history of studying pollinator biodiversity in urban and suburban community and residential gardens. Our past studies have looked at bees, wasps, a little bit with butterflies, and more recent studies with hoverflies or syrphid flies. I'm all about the syrphid fly these days just because very little is known about them in my region of the world, the Pacific Northwest. Most of the studies that have been done on syrphid flies as pollinators have been done in Europe, so I am really reliant upon the great work done by European biologists. In general, we've shown that gardeners can have positive impacts on pollinator conservation at the local level by planting more flowering plants and really making better decisions about the types of plants that they're planting. And I'll finish up by saying that one of the things that I find most fascinating about our studies are that I've realized over time that people are predictably, I think there's even a book called Predictably Irrational in what their overall goal is related to pollinator conservation and what some of their actions are related to pesticide use or maybe heavy management and mowing of their garden spaces. So we spend a lot of time trying to tease out what people are actually doing in garden systems, how that affects biodiversity, and how to communicate alternatives in ways that will be more acceptable to those gardeners. Thank you so much for having me here today.
Thank you so much for your introduction. Does Crystal want to go next, or Dr. Eleanor, whoever wants to go first?
I can go. So yeah, my name is Crystal Hickman. I'm a conservation photographer, National Geographic explorer, and community scientist. My primary focus is native bees. I particularly work with native bees in the Western United States, but I also travel all over the world to photograph them and document them as well. All of my research is through live identification. So I don't do any capturing or killing. I teach people how to get into community science and how to conserve native bees. But the primary focus is to educate people that to save native bees, you actually need to save the entire ecosystem. So I teach people about all of the creatures in the ecosystems, even things that they might not necessarily like thrips or aphids or wasps, but highlight how these are important to understanding and supporting ecosystems. Also educating people that nature doesn't really revolve around people, and because of that fact, it doesn't give you a reason to save it because of how it affects people positively or negatively. But yeah, I've worked on quite a few different projects to do this and support it as well. I also work with universities. I teach classes as well. Yeah.
Thank you so much. Both of you said so many things. I'm just trying to follow up with questions later. Dr. Eleanor?
Okay, let's see if I can get the screen to share. Do you know how I share the other window?
When you click on the share screen, there's 3 options, I believe. One is just one of the cards on the Chrome. There's the window, and there's the entire screen. I think the entire screen works the best because then we can see everything that you're sharing.
Okay. I have my presentation on. Yeah, I found that, but I have my presentation on the other window.
Yeah, you can see it.
Let me do this.
Yeah, perfect.
Okay, you can see everything now. You can see my presentation. Okay, it has the. Oh, did that stop sharing?
I think you're still sharing, but your presentation went somewhere.
Okay.
Yeah,
it had the display right over the thing. Okay. So I'm Dr. Eleanor Lichtenberg. I'm an assistant professor at the University of North Texas, which I put up a U.S. map here. We're near the Green Star, just north of Dallas in Texas. And in my lab, we're looking at plant-animal interactions under global change. And we have 2 basic goals. So one is to address basic ecology and behavior questions. And then we want to use this science to improve management and conservation. And we have sort of three broad questions that we're looking at in the lab, integrating ecology and behavior. So one is what are the impacts of management on biodiversity and interactions? And I'll show you a quick result from that in a minute. And then we also do some behavioral ecology, looking at how interactions with other flower visitors affect bee foraging behavior through the use of social learning. And then we also look at pollination, and I'll show you an example in a second. So on this first area, I've set up a project in these three counties in northern Texas in our study area, looking at how management of grazed lands, sorry, my cat is coming to say hi, is affecting biodiversity and interactions of plants and pollinators. And so we ask how management affects availability of both food and shelter resources, and then impacts on a range of flower visitors, including, so interestingly with the flies, they're mostly not syrphids that are visiting our flowers. And so my first graduate student, as many of you know, a lot of the research on sort of pollinator habitat focuses on flower availability. But my first graduate student came to the lab and said, well, ground nesting bees, they're spending most of their life cycle underground. So do soil properties affect these bee communities? And we found out that yes, they do, potentially even more strongly than floral availability. And so here's one of her sets of data showing that we're in a very heavy clay soil region. So having more sand in the soil and also less compacted soil increases bee abundance and richness. And then here's some of the other things we're looking at the impacts of grazing management and how traits mediate both interactions, sort of basic ecology questions, and then management impacts. And here are some of my other graduate students. And then on the pollination side, my new student Victoria is studying whether beetles may be important pollinators in temperate grasslands, because most of what we know about beetle pollination comes from a few plant groups in the tropics, but we see beetles very frequently on our flowers. And then I am collaborating with some economists and a computer scientist to develop frameworks and tools for better valuing ecosystem services, so that we'll be able to ask questions like, how can we balance pollinator conservation and farmers maximizing their profit? And already coming out of that, for example, we've published a paper, a computer vision model to detect honeybee hives in a landscape. And then I just have a few photos showing my lab at work, and also showing the area where we work, what it looks like. These are very large open spaces, and yes, with the heavy clay soil. So that is me, and I will stop screen sharing if I can figure out how. There we go.
Perfect. Thank you so much for your introduction and all of your introductions. We have some questions for the round table, but I did have some questions when listening to all of your introductions. Crystal, I'm interested regarding the determination through pictures. That's one of the things that we talked about a few times. I'm from Croatia specifically. There's very limited experts here, but it is our general notions that we have to kill at least once we have to kill one type of species per location just to have some reference base, that we really cannot determine the level of species through just a picture. So what's your opinion, and what's the margin of error when you determine through pictures, the photographs?
Yeah, well, the first thing is angles. So it's not just one photo. So I did a photo with dorsal, lateral, face shot from behind. The photos that I normally lack are the photos from underneath. So there are certain species that you can't identify if you don't have that photo. Also, there's certain bees like some Melisotis that you need to look at genitalia to ID. So that does limit them. However, even just I use a lot of times just identification keys, and it's just the plant relationships, the time of year, the time of day, the location. A lot of times you can actually ID to species because of that, or because of the relationships they have with other bees. So if there's a parasite, and a lot of times the parasites are easy to identify, you can actually identify their host to species, or vice versa, sometimes even subspecies. But yeah, it's basically knowing which angles to photograph, getting really high definition shots of those angles. And I actually incorporate bee behavior into my photography. So for example, if I see a bee on like a stalk of salvia, they normally like the stalks like this, and they'll actually circle up through the stalks, and I'll kind of wait on a flower that's pretty, but also I can get an angle like where I'm looking to photograph them from the side, and I can get those shots. But also too, I incorporate like male bee behavior. A lot of times they'll sleep out or in plants early morning, evening, through the night, so I can photograph them where they're not moving around. Um, Also, they kind of get used to you if you're spending, because I spend like maybe 12 hours a day out there, and they fly away from you initially, but then they get used to you and they kind of hang around, and you can get really close to them. And then sometimes too, I've noticed you could put your finger, they're like, oh, I really want a steady place to stand on, and then they'll climb onto your finger, which adds, you can basically do photo shoots on your finger and change the angle to make sure you get shots of their pores, different places of their antennae, sometimes even like the first segment of their abdomen, you need to get the pores on those. Also wing venation. But yeah, you could definitely do it. I've even, Dialyctus is a bee that a lot of people are like, that's impossible ID from photos, but you can definitely do it as long as you either have a key or an expert who can confirm ID with you.
Interesting, definitely. Yeah, hopefully that the photography community in Croatia and generally in Europe will develop more, so to the point we can actually make specific keys for determination through the pictures, through the photographs. But at the moment, most of the keys are based on morphological specific parts of the body that you really need to look under a stereo microscope. But right, starting with the questions, all of the questions today in each panel were similar because so we can offer people to compare different continents. And we do start with a little bit more bleak, depressive questions, then coming more to happier, motivated questions, so we can motivate everybody by the end of the panel. So starting just with the first question, what would you say are the biggest current threats to pollinators in North America? Whoever wants to go first, and whoever wants to go original.
Go ahead, Crystal.
So it's definitely changing, but I would say habitat loss is a huge one. A lot of times when I'm looking for rare, endangered, or lost species, I'll look at old keys for locations, and then I'll try and go to those locations, and I'll see there's a parking lot there or a building. And a lot of times people who are building these locations don't even know that there were some species here that were rare or that used to be abundant. But also climate change is a very big one. So we're seeing incredible swings back and forth, especially in California. We go from extreme droughts to just so much rain. And it's also kind of throwing off the timeline for flowers blooming. And a lot of times when I'm going back to the same locations to look for these bees year after year, I'm wondering, are they actually gone? Are they in an extended diapause? What's happening with them? But that, and then the third is obviously pesticides and herbicides as well.
I'll dovetail on top of that and say that climate change is really at the forefront of my mind lately, that we've had a very mild winter here in Oregon, just a little bit north of where Crystal is in California. I see bees foraging or attempting to forage for pollen and or nectar at times of the year when we wouldn't normally see them. There is a great study that came out recently from Europe, I think either Finland or Denmark, I can't remember, that showed that when bumblebee queens are going through intermittent diapause and are warmed and awaken from diapause with warmer weather, that they're just burning through their fat stores, their winter fat stores, and they're not able to effectively emerge to forage in the spring, or that they are smaller and have fewer energy stores to establish their brood in the spring. So I'm very concerned about all of the bumblebees I see foraging right now that should not be out. And then I have to say that living in the US right now with a federal government that is hostile to conservation efforts in general, we've had the loss of the a pollinator advocate and liaison at the USDA. That position has been cut. She used to do a lot of work to convene researchers around pollinator health and conservation issues, and that position is no longer there. Funding opportunities at the federal level to support pollinator conservation efforts have either disappeared or we expect them to disappear in the near future. That's been really difficult. Being able to support young scientists as postdocs to work on these projects is like a disruption to the pipeline as well. So those are kind of the two things that are at the forefront of my mind, are climate change and then also lack of federal support for pollinator conservation efforts or pollinator research efforts.
And elaborating a bit more on habitat loss, I think this is somewhat jumping ahead to one of the other questions, but
okay.
But the US is very big, very heterogeneous, and so the causes of habitat loss can be very different in different parts of the country. So, for example, up in the Dakotas now, there used to be a lot of prairie. It's being converted to corn and soy row agriculture. In places like on the East Coast, some of the biggest causes of habitat loss may be suburbs that are controlled by an HOA, where everybody has to have a really nicely like uniform and mowed lawn that is just grass. And so there's a lot of different causes of habitat loss.
Yes, HOA is it's a very meme thing, internet thing regarding USA. It's very interesting. Something that doesn't really come up in Europe, but it is the principle does come in the governmental way of keeping up with urban gardens. It is also very much just the grass and a few trees. And you mentioned that North America is very heterogeneous. So my next question is also kind of broad, but it is regarding the research challenges specific to working in North American environments. Obviously, just because you live there doesn't mean you've been to every part in North America, but what would you say that you think are more specific challenges for your area that other panelists in other previous panels today from different continents didn't face? Or you can just say your general challenges that you face.
I think sort of continuing on what I was saying, and this is, so I've been thinking about this sort of the US as a whole versus Europe as a whole. We have with our agriculture is often a lot more regionally specific. So now the Midwest states have turned very heavily to corn and soybeans. And I think probably places in Latin America are seeing the same thing as well. That just because we have so much space, this happens, that certain crops are grown in certain parts of the country. And this greatly reduces the intercrop heterogeneity across a landscape scale within a region. And my understanding is that in Europe, it tends not to be nearly so separated. Let me know if I'm wrong there. So that is, I think, one big difference. And it's a reason why in conversation with these economists that I'm collaborating with, we felt that there are probably some different dynamics in the US and in Europe when we're thinking about things like pollination markets or what things look like at the landscape scale in terms of habitat availability. It's just one thing.
Whoever wants to go first. Dr. Gale, maybe?
Sure. So Oregon is a little bit different in that we have a lot of agriculture in Oregon, but in the small slice of the Willamette Valley where I live, there are more than 200 specialty crops that are grown, and many of them are reliant upon pollinators in order to set marketable fruit. So we have a big berry industry, we have a big specialty seed industry, a lot of vegetables, a lot of orchard crops. And so I feel like the agriculturalist in Oregon, so first of all, we have a more diverse agricultural landscape than many parts of North America. And because of their reliance on pollinators, I feel like the growers really they recognize the importance of pollinators to their economic health and bottom line, and they want to conserve pollinators. But at the same time, they are pressed to meet like high aesthetic demands of the fruit when it reaches market. And there are very few tools that they have available to them that effectively suppress pests and also protect pollinators. So I don't want to always be like, funding is an issue, but there isn't a lot of support for research into biopesticides or softer pesticides or alternative management tools, which are going to be necessary to grow fruits and vegetables at scale. And so oftentimes the growers are just left with the default of the older chemistries, which are absolutely more harmful to both human health and pollinator health in many cases.
I'd just like to piggyback off of what Gail said there as well. So farming, I've started working with a lot of farmers in the last 3 years, and a lot of them are very interested in pollinators for their crops, but it's also kind of an education issue because a lot of times when farmers think of pollinators, they think of honeybees, and there's also sort of a direct one-to-one benefit, which is when you could put the hives next to farms and physically see them and then just assume that these are the bees that are doing all the pollination, and then you also get profit from honey. So it's visible, but it's a lot of times at the expense of the ecosystem. And I'd say one of the issues as well, specifically in the Western United States, is we just have so much biodiversity here. There's so many different ecosystems in such a small area that when you talk about saving areas, it can get just so compact and so small that a lot of times people outside of those specific areas don't really see how it benefits them. So it does sort of run into a lot of like funding issues just because there's so much going on. There's so much to look at. There's so much biodiversity, and it just sort of overwhelms people. Whereas a creature like a honeybee, you can target so much easier, and it's harder with ecosystems.
Yeah, thank you. I'm glad that we went to more topic about agriculture. So in Europe, when we talk about the farmers, when we talk about them with them about conservation of pollinators and working with them to get them on our side, one of the methods that we already discussed in a couple of different panels today is that you talk about it from economical standpoint, basically telling that if you conserve pollinators, you will get more product, more profit, etc. But when we do it, we talk usually with smaller farmers, usually on the smaller scale. But United States, for example, from my perspective, you have very big farms, larger fields, everything. So how do you approach farmers and food production facilities, and how do you work it out with them to get them on your side to conserve pollinators?
I can start this one, but I guess the best example I have is there's a very large farm in Central Valley in Helm, California called Terra Nova Ranch, and they started working with the Xerces Society to incorporate indigenous practices into their farming, which is seed banking, also hedgerows, and incorporating pollinator habitats. And one thing that really helped with them is this is a very established farm that's been around for a while, and it's kind of like, I don't want to call it like an influencer farm, but it basically is. So a lot of other farmers actually started visiting their area and learning techniques from them. And that started branching out into these smaller farms as well. So we're starting to see smaller farms incorporating pollinator habitats and starting to understand biodiversity. And because of that, there's larger companies like, I guess I don't want to say names, but they're also supporting this as well through funding. So honestly, it's just kind of like leading by example and showing that one, it can also be profitable. So instead of relying on a single invasive farm animal, you have a whole ecosystem that can pollinate your crops and potentially give you a higher yield. And also because you have creatures in the hedgerows or the habitats that will control things that you consider pests. It also can possibly lead to using less pesticides or herbicides as well. And then seed banking off, obviously selling seeds and working with other companies can be profitable.
Yeah, farmers, they're going to listen to other farmers much more than they'll listen to researchers. And so finding those people those farmers who are already interested in trying out different techniques and maybe farming more sustainably, and developing a relationship with them, which can take many years, then eventually you hope helps reach their neighbors, basically. But also, so where I am, where our agriculture here is almost entirely ranches, and these are we're rangeland, so this is largely natural area, and these are big properties. It's not like pastures, a pasture system. We don't have enough reindeer to have pastures, and so a lot of the older ranchers were not interested in changing what they do, but it seems like a number of the younger ranchers are interested in using regenerative practices, but they're not going to be driven by caring about pollinators. They care about things like reducing erosion, and healthy soil that lets them grow more forage. So figuring out what it is that the farmers care most about, and then seeing how pollinators tie into that can be another way to have a conversation. But it takes a lot of on the ground work.
Here in Oregon, it's a unique system in that there are these things called commodity commissions that are set up. So there's a hazelnut commodity commission, there's a specialty seed commodity commission, there's a berry commodity commission, where the growers agree to tax themselves, let's say like 5% of gross sales, and that money goes into a fund that then supports the research and education needs of the growers themselves. And so there are pots of monies to support the research needs of specific cropping systems. And what I've seen happen is that one commodity came up with a pollinator protection plan, like a research-based pollinator protection plan that everyone decided they were going to sign on to. And then that just kind of started to a domino effect where like other commodity commissions were like, we need a pollinator protection plan too. And in part it's because in Oregon, and sometimes a state has like a reputation for being like a sustainable state or like a hippie state or like a green state, that the consumers are asking, the consumers oftentimes have the ability to like go on farm and talk to their grower or meet their grower at a farmer's market. And the consumers are increasingly aware of the importance of pollinators, and so start asking, what are you doing to protect pollinators? And so just recently, we even had the Oregon Wine Grape Commission come out with their pollinator protection plan, which floored me because wine grapes are not even pollinated, like they're grafted, they don't need pollinators. So it's just like been this really interesting dynamic conversation between grower groups and also between consumers pushing the grower groups to demonstrate their commitment to pollinator protection, which I think has had a wonderful effect overall for efforts to conserve pollinators in our state.
Yes, one of the interesting examples, and I can think about where it was like a documentary, and it is a place in the United States that they, it's a valley where they grow alfalfa, but they grow it for the seed, and you probably know the example. And it was really interesting concept because in the documentary you can see the farmers doing everything they can to protect these pollinators because they need them to pollinate the alfalfa because the honeybee is not a good pollinator of that plant. And they did all kinds of different things related to promotion of the bee and everything. But one interesting concept is that they created these mountains of sand, so the Nomia bee, I believe, can nest. And that's to me, the first example that I see that anybody can, well, artificially rear soil nesting bees. So very interesting concept that I would love to see tried in Europe. We don't have Nomia, and we don't have I don't believe we have any species that would form that big of a colonies, but still you can attract different solitary bees in accumulations that they usually create. Right. Following upon that, how do you approach public communication and education about pollinator conservation? And how can we make pollinator research more inclusive and accessible to young researchers and also local communities? Again, whoever feels to go first.
I could start. So I guess the first thing I would recommend is just kind of letting communities lead themselves, because communities are most aware of what's going on, what they're dealing with. So they know the nuances more so than people coming from outside. So me coming from the outside, what I bring is knowledge as far as pollinator health, habitat, and then I guess what is going on in their areas, like what the history is. For example, I have a friend who lives in South Central LA, and it's basically cement everywhere. And in areas like this, it's also there's less green area, the temperature is higher. But what we started doing was incorporating regenerative landscaping into her yard, and just the visibility of that has led people to stop by and ask questions. So I think that's the main thing too, because like a lot of what I do also, there's kind of a barrier with finance. So a lot of times people don't have the affordability or the time to do it. So while kids are in school, they can visit these yards, they can get free access to the gardens. Also, just explaining to people you don't need a really high tech camera to photograph things. You can use your cell phone. Everyone uses that while they're walking around their neighborhood, while they're going on hikes. And then also just encouraging people that your yard can be a habitat. It can be sort of like a native landscaping bridges between places. So just kind of meeting people where they are and allowing people to just find their own way to get into conservation or nature. Because obviously my focus is bees, but a lot of other people love birds or hummingbirds, same birds, but butterflies, different creatures like that.
I echo what Crystal is saying, and then also Crystal's general approach of taking gorgeous photos and making things which oftentimes are inaccessible or may escape the attention of, just the casual viewer or walker through a space, just to help people to understand that there's like this, quasi-secret world that most people are unaware of, with like amazing interactions going on all around them. And you have the ability to see this space and access this space. I think the power of storytelling through photos, through film, by dynamic lectures, and just helping people view things in a different light. I was born and raised in a fairly urban area, Baltimore City, Maryland, and didn't really have a lot of opportunities to explore natural spaces outside of like baseball fields or softball fields. And then when I went to college and had the opportunity to go into a forest for the first time, like I describe it as like this scrim was lifted from my eyes and I saw the world in an entirely different light. I saw spiders like in a way that didn't scare me, and recognized that like at night their eyes reflect light back like a cat's. And the forest that I was working in was outside of Washington, D.C. So even though they had deer, they were fairly inbred. So there were albino deer in this forest preserve, which like blew my mind. And just the natural world is just wonderful and amazing, and many people don't have opportunities to access natural experiences, but if and when they do, it really can be life-changing. You know, it was for me. And so I think that the power of storytelling, building bridges and giving people access to these spaces and experiences, people, I think it's Robert Michael Pyle who says, like, what does the plight of a condor mean to a child that's never seen a wren in their backyard? And I know I'm butchering that quote horribly, but just making nature more accessible to people can make a really big difference in perspectives and intentions to conserve and protect.
I agree with everything that Crystal and Gail have been saying. I'm also from Maryland, but right next to Washington, D.C., so also a very urban space. I'm just going to give a few sort of more specific examples. So a lot of the pollinator labs throughout the country will participate in various types of community events. So Shalini Jha's lab, for example, went to the San Antonio Rodeo and had a table there where people could stop by and learn about bees and pollinators. My lab is doing events in the Dallas area, where we just, whoever's there and wants to chat with us. And again, the types of things that Gail was saying, like just sort of starting with the very basics, like there's more than just honeybees, and whatever they're interested about, trying to broaden their horizons a little bit and let them know some cool stuff about pollinators. And then with my lab also gives, and many labs do this, gives some talks as well. So to gardeners or ranchers now I'm talking with, and the approach I've taken here, because these are people will say, well, what can I do? And so for these longer talks, the approach that I'm taking is to give the group a bit of basic knowledge of sort of basic pollinator biology, like meeting flowers throughout the entire active season, where they're sheltering, so that they can figure out what sorts of management at what sorts of scales are going to work best for their specific conditions. And in terms of, you mentioned making pollinator research more inclusive. So thinking about kids that come from an urban background, and at my university, a lot of our students are from Dallas, is giving them these experiences where they can be just super excited about nature, but also thinking about things like making sure we are informing them what they need to be safe when they're going out to do field work with us for the first time, for example. And a lot of our students are lower income. My lab started sort of like a little bit of a field clothes borrowing drawer. So our university surplus had some long sleeve shirts that were fairly large that they were giving away for free. So they're available for the students in my lab to use for doing field work with us. We do long sleeves for safety from the sun and ticks and brambles and things. So yeah, so there's I think one limitation is that we have pollinator researchers only at relatively few number of universities, and so those are the students who are mainly going to get exposure to pollinator research.
Thank you. In the beginning, Gail, you mentioned syrphids, and I got reminded about the new book of syrphids that came out from the neighboring country in the Balkans, from Serbia. It's a very good book. I can send you. So I'm wondering about do you have problems with determination keys, the lack of them in your country? Obviously, in Europe, one of the problems that we have is determination keys to the level of genus are now existing, but to the level of species, most of them are either in German, French, Latin, Spanish. So if you don't really speak any of those languages, you have to, Google Translate, and then, so that's one of the problems that we are facing. Plus, most of them are very old. So what is your situation with determination keys, and even just the people who know how to determine different pollinators?
I can, so this is a huge challenge in Texas. We're a big state, but we are very challenged when it comes to taxonomic keys. So we think we have about 1,300 bee species, and California has, in Texas, California has even more. But many of these species are still not described, or the descriptions that do exist, we know, are inaccurate. Texas seems to get left out of the new keys that are being developed as well. So in some cases, we're using keys from the 1920s. We have one taxonomist here, one bee taxonomist here in Texas, and he is close to retirement age. There's very little funding for taxonomists for taxonomy research in the US. So identification is a very big challenge here, especially if you're in parts of the country that sort of get overlooked by the keys, because we can't even do it ourselves then.
Yeah, I'll say for the keys here, I feel like there are quite a few bees missing, and the identification keys are also very old. And going through them a lot of times, I feel like they were written by people obviously very knowledgeable, but maybe not particularly with the readers in mind. So the understandability of them is sometimes complicated. For example, I had to figure out with some osmia bees with an older key, like what did shiny versus semi-shiny, not shiny, like what did that mean exactly? Or there's a lot of people who are experts who spend so much time in the field and understanding this information, but it's in their head. So there's certain bees, or certain genera where you just have to reach out to the person who's an expert, and then you send them photos, and then they tell you what it is, and you kind of have to just hope that they're accurate. I've also read keys where they say a certain bee looks like the female of another bee, and then you go to that key and then there's no description for what it looks like. But yeah, they take so much time to edit and update that and I also feel like maybe funding for it isn't, I don't know where it used to be, but especially the 40s, 50s, even into the 60s, there seems to be a lot of work with creating and updating new identification keys where I feel like maybe that's just not the case anymore. And I'm not 100% sure why, but yeah.
Yeah, I think as an insect ecologist, I recognize that I'm completely dependent upon the expertise of taxonomists. I don't identify any of my specimens on my own. I'm completely dependent upon people who've been trained by Dr. Packer to identify those difficult lasioglossum. My first faculty position was in New York City. So I was just down the street from John Asher when he was at the American Museum of Natural History. And so doing everything possible to stay in John's good graces so that he will identify my bees or refer me to someone who can. And then I think from interacting with John over the years, he's made very clear that taxonomists not only aren't supported by funding lines or competitive funding opportunities, but oftentimes they're left off of the publications of ecologists who depend upon their expertise. And so I try really hard whenever there's an opportunity to raise attention to the fact that none of this work would be possible if we didn't have expert taxonomists to lean into, to credit them appropriately in our journal articles where they identify our specimens. We absolutely provide authorship rather than acknowledgement. And Yes, honestly, just doing everything I can to stay in the good graces of taxonomists, because if I did not, my work would absolutely not be possible.
And I should give a quick, speaking of acknowledgement, a quick shout out to the people who are, one great thing we do have here is Discover Life and the bee keys that have been developed on there. Although again, Texas can be tricky, but there's some really, really great photographs of the features that they're talking about, some really great keys that are being, or I don't know if they consider them keys, but identification tools where you won't necessarily get stuck at a couplet, because you can choose which pieces of information are going into the decision-making process. So Discover Life is awesome. And thanks to everybody who helps maintain it.
Yeah. Also, I do want to mention about Discover Life. There's graphics of bees, the body parts, and they're like labeled with names. So when I was first learning to identify things myself, that was so helpful. So yeah, again, Discover Life.
Yeah, following on this question that I asked also on the South American block panel, what is your opinion about eDNA methodologies regarding pollinator research? Do you have any experience with them? What's your standing on them? Because it's a newer methodology and it's very different perspective from different people.
Well, I'll say that in my position as a subject editor for environmental entomology, we're seeing more and more eDNA papers come through for publication consideration, and it's difficult to find a body of experts who have the entomological and molecular expertise to effectively evaluate how these papers should be reviewed. And so just noting that that's like one issue, is it's so new that even how to evaluate the work is challenging from an editorial point of view for a professional society journal. And I honestly don't have enough expertise in that area to know one way or the other the value. I think it's intriguing, but my understanding is that right now it can tell at best presence, and that's kind of where we're at. Not necessarily even absence or abundance or interactions, but it's an intriguing tool for potentially being able to tell presence of different species in difficult to study areas.
I also agree that it sounds very exciting, but it's not something I'm currently incorporating. I do know someone who is trying to develop eDNA sampling for rare species to detect it sort of across the state. And a very big challenge they've run into is that they haven't been able to find the species to get voucher material so that they have a genetic reference for it. So I think it's still facing a lot of challenges. Hopefully it will be an option in the future.
Yeah, I also agree. I think it's really intriguing, or obviously at the very early stages of it, but I am working with someone who is using it very experimentally to find lost or possibly endangered, maybe extinct bumblebees. But yeah, like you were saying, getting the actual reference material to compare it to the DNA, that is a bit of a challenge with these species. So I'm really curious to see where it goes in the future.
And well, following also on the topic of agriculture and farmers, recently I had a talk with a couple of colleagues that it would be interesting to have an app where you can, or a program, whatever, where you can enter when some crop is flowering, and then when some bees are flying, and kind of connect them with the literature of what pollinates what. And then you can use that to offer some sort of services to different farmers, where you can analyze their farm, you can tell them what's growing, what they can plant more, etc., etc. But specifically in my country, with the economy is not really developed in a way that any farmer would be interested to having that option, because we can't really offer him anything. You can't offer him those bees, and in most of the Europe you can't really offer native seeds. So is the situation different in USA? Do you have the options to, or do you have companies that produce native seed packages that are actually native?
Yeah, and that's, I think, a growing, although at a small scale, industry in the US. Is there is a lot of interest in native flowers, including in more urban areas, although the seed packets are sometimes it's like the ones I get down here include species that are really from the northern prairies that aren't native here. But there is a definite interest, including into incorporating native plants into yards, which does raise the other issue of the genetic sources of those seeds. Are they appropriate to the region? And then there are other companies. So I worked with a company up in inland Washington state that they have sort of the more conventional side of their farm that's growing the crops that are typical for the region. But then they also have a business growing native seed as well that they sell locally.
So I work with two organizations. One of them is called Hedgerow Farms and Xerces Society. They'll seed bank from specific areas, and people who are purchasing the seeds can be very specific, like, oh, I want seeds from within a certain mile radius of where I'm planting them. So they can make sure that they are definitely specific to the region as well. But a lot of times too, I've been finding that farmers, besides like the nomia bees that you mentioned before, which are native to the area, with the alfalfa farming that's happening in Imperial County, California, a lot of times they're bringing in the habitats. They're doing really good jobs with the native plants, but then they're shipping osmia bees from the East Coast, or I saw some from like Japan, which was kind of interesting. But yeah, they're getting there. It's baby steps, but yeah, it's just, I guess, understanding what native is and why it's so important to be regionally specific.
I work with a lot of native plant growers because interest in native plants and gardens has exploded. And so the United States does have a national native seed strategy, because during the Biden administration, they recognized that there was a lack of native seed supply to restore habitats after wildfire. And then if you were a commercial native seed grower, it's difficult to, a lot of your production details need to be initiated like 2 to 5 years before you need to meet a contract to deliver seed. And so it's hard to plan for that with these natural disasters and large-scale wildfires and other events which are really unpredictable. And so I feel like that support of the National Native Seed Strategy gave funding and gave good guidelines for how to increase the supply of native seed to meet restoration needs. But now we're kind of like at an interesting spot where the restoration market is distinct from the ornamental market. And you have all of these gardeners who have heard about the value of native plants to protect pollinators from the work of Doug Tallamy and others. And they're really anxious to purchase seed and to plant them. And, we just did a full-scale survey of Oregon gardeners, like what was actually being planted in their yards. And we're noticing significant shifts towards more native plants in their yards. But I think it's confusing at the point of sale, where The restoration market for native seeds is relatively pure. People understand the importance of genetic provenance or not selling seed outside of the region where it's native. But in the ornamental market, it's kind of like no guidance or rules, where people are selling things that are outside of its native region. There are a lot of selected cultivars that are for sale, and the consumer can't necessarily tell the difference between the two. And so it raises interesting questions about what does the enthusiasm for native plants in the ornamental market, what might that be doing for the population genetics of native plants in the wild? Yeah, so there are people that are producing seed. It's much better organized in the restoration market. The more I've learned about what it takes to produce native seed, I kind of joke to myself all the time that you don't need a lot of land. You can produce a lot of seed on relatively little land. That when I get frustrated with academia, I'm like, I'm just going to be a native seed grower in my backyard. That's what I want to do. So yes, there are people that are supplying the seed, but kind of depending upon if you're coming from the restoration market or the ornamental market, the quality of that seed may not meet the end goals of conservation, may or may not meet the end goals of conservation.
And we already touched upon this, but just to follow up with a question regarding honeybees. So they are European of origin, but even here they're kind of considered invasive species, mostly because we are spreading it so far. They can't really survive on their own in our nature, but our beekeepers on larger scale, they have up to 500 beehives, which is obviously detrimental, very bad for the rest of the environment. So I'm wondering, do you have the similar problems, specifically because they're not native to your continent?
Yeah, there's some papers that have been coming out in the past few years that are specifically looking at whether and how honeybees are impacting native bees, with impacts falling under a few categories. So you have competition for floral food, and then disease transmission at flowers is another big one. And some of the more recent studies are finding effects, some don't find effects. I think we don't yet have a big enough body of research to definitively say these are the effects, but it is definitely a large concern here. And there's been a sort of a trend in the past few years of comparing honeybees to chickens, and that they're sort of live and thinking of them as livestock. So that goes around on social media every once in a while. And of course, the advantage of honeybees is that you can put large numbers on a field at any one time. And we actually have some organized markets, basically, and the economists that I'm working with sort of tracked the history of this, where the best organized one is you have the bees. So the beekeepers, they'll overwinter the bees somewhere, and then they take them to the almond pollination in California in like February, and that's actually the large what's driving the demand for honeybees. And then they go up the coast into the like Oregon and Washington berry crops that Gail was talking about, go start tracking eastward, then spend the summers in the prairies in like Dakotas, Minnesota. So the beekeepers they'll get some honey from the bees then, but there's not a huge honey market here. But so in some there is this very organized sort of circuit that the bees track, the honeybees track throughout the year, so that partly so the beekeepers can feed their bees year round, because there's such a high demand for almond pollination.
I'd like to add to that too is, so Southern California, where I live, the honeybee populations have just exploded. So I don't know if what's happening here is a reflection of what's happening across the entire United States because of maybe the difference in honeybee populations. But one thing that we've found, especially in drought years, when there are less floral resources, native bees, which can be specific to a certain time of day. Like sometimes they'll start to show up around 10 a.m. or when the sun's directly overhead. Honeybees, because they're actually tested, they're the ones in Southern California at least are genetically one subspecies of an African honeybee as well as multiple European ones. And they just seem to show up as soon as the sun rises. They're out midday when it could be over 100 all the way to the evening. So a lot of times it's not just other native bees that they're impacting, it's also pollinators. So they can possibly take the resources from these flowers before the native bees are even up and flying around. And a good example of kind of an observation that people made in the 80s and the early 90s was with the Channel Islands. So I think it was Santa Cruz Island that never had any honeybees introduced. And militologists were going there and they saw that there was just a lot of pollinator diversity, and they were comparing it to Santa Rosa Island, which is nearby, which did have honeybees, which also had lower pollinator diversity. So what they actually did was they went to that island, they introduced, I think they introduced varroa mites and ended up wiping out the honeybees, and started to see that pollinator diversity did increase. And I visited those two islands specifically, and it is kind of just amazing to see how much diversity there is as far as insect pollinators. But yeah, like Eleanor was saying, there's also disease spread. Specifically, I've been looking at deformed wing virus just because it's very easy to observe physically, and how that's being spread to bumblebees. But yeah.
Go ahead.
Sorry, we have anecdotal data from our studies. We do a lot of native plant pollinator interactions. We have a high proportion of specialist bees in our area. About 35% of the bees are thought to be specialist pollinators dependent upon pollen from specific plant genera or plant families. And we notice that when honeybees don't have other things to forage upon, like Crystal was saying, when there are drought conditions, for example, that it intensifies and competitively excludes the specialist bees in particular, which aren't able to shift onto other floral resources. So we're following up on that to see whether or not the planting of what we're calling magnet plants, or other people have called magnet plants, which push out a high degree of nectar, if that can like pull all of the honeybees onto that magnet plant and thus leave the native plants, which the specialists are dependent upon, leave that forage more available for the specialist bee fauna, and potentially allow greater coexistence instead of competitive exclusion.
That's actually a very, very interesting concept. I seen well, I'm not sure, was it a master thesis or just a poster, where they compare how the pollinator network changes based on introduction of different invasive species to flowers. And based on that data, it seems that introduction of this, not really sure what's the name of the tree, but it produces a lot of flowers. All of the wild bees and honeybees, they change their pollinator network. Basically, they do pollinate that plant, and they pollinate less of the plants that they would pollinate without that. But it would be an interesting concept to try to use this, not necessarily invasive, but not native plants that flower a lot to attract honeybee who is invasive. One of the problems that we are facing in Europe is that every type of funding related to bee research or bee conservation is open for the honeybee beekeepers to also apply. So they're taking a lot of funds. And the other problem is that they have the ability to go into nature reserves and protected areas to place their hives, which is obviously a problem. There was this similar research in one of the Italian islands, where they shown that the honeybees are detrimental to the rest of the wild bees once they were removed, because they were on, I think, on trucks. Just in a couple of years, the wild bee population exploded. So yeah, going further to this maybe bleak topics, how would you say that the do you think it, how do you say that how do I form this question? It's late and this is a long event. Regarding the climate change, just to backtrack on that topic, do you see a bigger shift in the North American pollinators in their range and distribution and biodiversity?
So I think something that that goes back to what I brought up before about the US being very big, and also what Gail was mentioning earlier, is that there are some studies showing some range shifting, or like going further up mountains. But a big challenge for us here in the US, especially for drier parts of the US, we span deserts to rainforests in different parts of the country, and sometimes pretty much within the same state even, is these really big swings in precipitation. So we're having more extreme droughts, more extreme flooding events, and we don't know if the bees are able to survive, like how many bad years the populations are able to persist in. So that may be a more immediate threat than just increasing temperature and range shifting. But we have no data, I don't think.
Yeah, I think one thing to add to that too, I feel like this is a great way community scientists can get involved. For example, I have a friend who's retired, so he just has a lot of free time and he's obsessed with bees. So he spent the last 6 years going to the Santa Monica Mountains, sitting on this one patch of trail for about 3.5 months for every single day. And I think it was 2 years ago, he's been observing there's a aggregation of Diodacia bees that live there. And 2 years ago, a species that he'd never seen just came up out of the ground in the place that he'd been sitting. And that was a sort of observation that a lot of people will miss because they're literally not just sitting there for years on end. Yeah, sometimes I wonder going to these places, like there's certain bees that show up every other year instead of every year. Is this just a normal part of their cycle? But there's also bees that we're seeing year round when they shouldn't be year round, or I don't know. I just feel like there's a lot more questions than answers, and I guess maybe I don't really have the best answer for that. But there's definitely shifts, and I feel like maybe looking back at this 50 years from now, it's going to be very evident what's happening. But right now, it just seems to be kind of a mess of a lot of different information.
I don't have anything to add on that. I think that Eleanor and Crystal covered it quite well.
Thank you. So here's a more of a philosophical question, I suppose. How can we better balance economical development with pollinator conservation goals?
Well, I can tell you that the economists that I'm working with think we currently are not doing a very good job. They politely laugh at us. They're really great to work with. But that was a big part of our motivation for this collaboration that we have to develop. So they feel as pollination ecologists, there have been some studies that have done a little bit of evaluation showing, and that basically show that yes, pollinators can be important for crop production, but we're working to develop tools that are much more specific and fine-grained, that will be able to let us ask questions like, in this specific region where you've got roughly like this much, this type of landscape, and people are using these sorts of managed bees and growing these crops in this type of region, what's the balance of managed bees and setting aside habitat for wild pollinators that maximizes farmers' profits. And so I think we need to be working on tools like these, that the economists also had not been working on these tools for really valuing ecosystem services in ways that let people ask specific questions for their specific circumstances, using one sort of broader tool. And so we're really excited about what we're going to find. So, but we don't have answers yet.
Yeah, so I was just kind of thinking at this as more of a personal standpoint. I feel like with honeybees, it's very easy to see the benefits financially, whereas with native bees, a lot of times it's down the years, and because of that, people who are studying them are running into financial issues, especially with the current administration, federally funding, especially. But honestly, like a lot of the work I do, it's self-funded. A lot of the other people I know, one of my friends in Australia who's a bee expert, she has like a Patreon. So you have to just kind of be creative with where you're able to like get money from to pay your bills while you're going out and doing these things. But yeah, I wish there was a little bit more research where we could find the financial benefits for everyone. So I feel like this work is very important. I don't really have an answer for that one either, but yeah, that's where I am at the moment.
Yeah, I think it's tough. And I think that the carbon credits market, and at least in the US, the failure of the carbon credits market to really take off or to be supported to promote more climate friendly ways of economic development doesn't bode well for developing a market for ecosystem service credits, for example. I wish that there were better news, but on the local level, we're seeing that agritourism and having pollinator friendly sites on your farm as a visible sign that your farm is committed to pollinator protection, that's driving tourism dollars in our agricultural landscape. And as I said earlier, I think that the growers definitely recognize the dependency of their economic continuance with pollinator conservation. So we're seeing positive movement in that way as well.
And also at the local level, there can be action by, especially I'd say in more urban and suburban areas, action by local city governments relating to how they're either managing the land that's owned by the city or the county or whatever. So for example, my city is starting to try to implement a low mow program in areas that are technically park that are owned by the city, but the areas that are not being used for like playing fields and playgrounds and things, to try to have that as habitat for pollinators. And I don't know if there are areas that have required HOAs to allow more pollinator friendly lawns or not. But there are some folks further south in Texas developed a seed mix that you put in as a lawn that it's got a lot of different little flowers in it, and it I think doesn't need to be mowed or is else does fine with mowing and is not just thick grass. So still can be kept short to look good, but also is providing resources for pollinators.
I'm wondering if, because locally in neighborhoods, the LA Department of Water and Power offers tax rebates for native landscaping, incorporating watershed approaching, and also for low income areas, they'll actually pay to basically convert your yard from like a European green grass lawn to a native habitat. And farming, I know they use so much water. I wonder if maybe that watershed approach could be incorporated into the farming as well somehow, some sort of a rebate. I don't know, but yeah, that would be kind of an interesting thing to look into.
The economical approach to trying to find some sort of governmental funding for keeping up with pollinators, conservation of pollinators. It's interesting in Europe. We talked about this morning, that the northern part of Europe, where the agriculture is more developed, more industrial, they are paying they're funding the farmers to slow down basically their farming and go more traditional or just more ecological, while in the southern part of Europe, where farming is more ecological, more opposite of industrial, they're paying them to increase their farming because they want to produce more food. So it's ironic, but yeah, it's an interesting concept to think about how we can have either tax cuts or different types of governmental funding to protect these natural areas.
We do have something here in the U.S. in areas that are growing crops called the Conservation Reserve Program, or CRP, where the government will pay a farmer to take part of their land out of production, and they have to plant it with a certain seed mix, and they're supposed to leave it out of production for a certain 5 or 10 years. And there are parts of the country where I think historically those seed mixes were just mainly grasses, but there are parts of the country where the CRP mixes that are being recommended now do include some flowers in them as well. And so that can help put in, at least temporarily, some pollinator habitat in areas that are heavily agricultural.
Moving to, I guess, more positive topics, what are some emerging trends, tools, or even methods that excite you most about the future of pollinator research?
Well, I do have to say that I have I don't know, I'm trying to figure out how I feel about AI. But I am excited about advances in computer vision and AI to increase effectiveness of photo identification of pollinators, both as a research tool, but also to make nature more accessible to the general public. That is one thing. I think it'll be interesting to see the effect of AI in conservation research writ large, pollinator research in particular. But advances in computer vision and identification are exciting to me.
I just think cell phones, the fact that everyone has them now, and I know this is with iPhones, I'm not sure about Samsung, but you can take raw photos now where you can edit them, and they have macro lenses that you can attach to them. So you can photograph really tiny details and learn how to edit them yourself and you could ID things. And I feel like it is it was initially a barrier to entrance for science. Initially was you'd have to go to college, you have to get these degrees, you'd have to spend all these years doing this stuff. You studied science in a certain way, but now you can do it just while you're going out on a hike. And there's apps like iNaturalist that can connect you directly to people who are experts in the field. So you just upload your photos and you have a direct one-to-one communication with them. And I just feel like being able to have that access so easily in your pocket, in your phone, is really wonderful. And I feel like it's getting so many more people into science, and it's also changing the way people visually see scientists, because typically it's you have a picture of kind of an older white man in a lab coat, and I'm completely opposite of that, don't even have a lab coat. But yeah.
I agree with both of those. And yeah, my lab mainly uses our lab coats when we're painting things. So I think on the sort of more research intensive side, something that I think we sort of have potentially now accumulated enough data to start doing more of that. I don't know that it's an emerging trend yet, but if you take any one hypothesis related to pollinators, you'll find studies that support it, that don't support it, that have mixed support. And so I think we're at the point where it would be really great if we can understand the context dependency of these responses in a more systematic manner. And that would let us have a more predictive science in general.
Thank you. bigger question, but what kind of international collaborations do you think are most needed in the next decade, and where should the global pollinator research priorities be focused by 2030, let's say? It's a large question, I know, but
I think there needs to be more support for areas of the globe where we know very little about pollinators, and getting funding to support pollinators in the Southern Hemisphere in general. Large parts of Asia where there isn't as much information as we have in North America and Europe. Yes, there's a big world to study and to discover, and I think that there are just some regions where we're not seeing the papers come out on even just what the pollinator communities look like in certain regions of the globe.
I would just say communication with other, in my case, militologists in different parts of the area through social media is really helped to identify where we're lacking information, kind of like what Gail was saying. So now that we know more, we know that there are areas where maybe we could send someone there and just kind of do surveys or studies and fill in those gaps. But yeah, specifically with the US, just because of funding, I feel like specifically with like the UC system, we've started to create little pockets organizations where we're supporting each other and sending people out to different different conferences, like the UN, for example, just to globally connect with these people in person, because there isn't a lot of outside funding or support from, I guess, the government or agencies a lot of times.
Yeah, I agree with Crystal that facilitating communication to figure out how we can, what sorts of international collaborations are going to be productive and how we can implement them. So to take an example from, part of my research deals with traits. And so it turns out that there are multiple groups working on making sort of centralized insect traits repositories. So there's a group out of Portugal, or studying the like how we're using insect traits and what this can tell us. We've got a group in the US, there's a group largely in England, and we recently found out about each other, and also some folks in Australia, and are starting to talk, which lets us sort of divide up the work and identify this group's going to focus on this group's going to focus on this, so that as a whole we can be more productive. It's also really exciting to hear what folks are doing in other parts of the world, and so like an online forum like this is really great for that, given how difficult it can be to travel to various parts of the world, or even within the US.
Yes, one of the idea of YEP in particular is to be a sort of a network that connects young researchers, but also general researchers. We are trying to have sort of a web page where you can see every institute, every company that works in bioscience, but it is a large task to do. One of the idea also of this event was to think about maybe not necessarily just for pollinators, but maybe also have a global network, even just an email list. But it is it's a concept that needs to be more thought about, maybe with some IT experts. But yeah, I was wondering about the interest in pollinators, and from your students and younger researchers, how high is it in USA? And what are their opportunities? In Europe, precisely right now, there are starting to be new funding for pollinator conservation. Sadly, not a lot of them are really related to potential PhDs, so not really academia and research. Most of them are for companies that would gather the data. So there are the market is growing for people who know how to determine samples, who know how to collect them, but it is growing slowly, and it's only growing because the European Union is now getting grants and opening new positions. But it is very hard for people who want to study, who want to do PhDs on these topics, because there's not really a lot of open spaces for research right now all across Europe and specifically in some regions. So what is the situation for younger researchers in pollinators in your areas?
Well, I think in general, researchers, but also the general public, there's definitely an increasing awareness of an enthusiasm about pollinator conservation, like save the bees, and also plant conservation as well. We have people that are getting into native plant conservation, which of course should help the pollinators. So I do like talking to people. There is enthusiasm for that, and we have here also we have just a limited number of labs that are studying pollinators. It has been increasing as those labs have trained other people who have gone out to get faculty positions. But yeah, it's if you look at sort of where bees are being collected, say, you see that what we are learning does come from some very specific parts of the country where the bee researchers are. So there's a limitation.
In my area, enthusiasm is very high for pollinator conservation. I have way more interest than I can support students in my lab. I'll also say that like my funding's very unusual in that I worked with gardeners through university extension services for many years. I was our state's Master Gardener Coordinator, which is a volunteer education program to support sustainable gardening. And then I started dabbling in research and sharing what my vision was for like a garden-based research program. And so my funding is very small from competitive funding agencies, and the vast majority comes from private gardeners who collectively agree to give like $200,000 a year so that I can support 2 to 3 students per year. So even that's pretty limited. I wish I could take in more students, but I also realize that I'm really lucky in that one of the gardeners that supports my work was a professional fundraiser and was like, I'm going to do this for you. It's like, I feel so lucky. I wish I could take more students, but then even when I'm training students and I'm realizing they need to go out on the job market, my biggest fear is that they're going to not be able to get a job because jobs are sparse. But luckily, I'm seeing like more opportunities in the nonprofit sector through Xerces, through the Institute for Applied Ecology, through Project APIS-M, through like more of my students are graduating and getting jobs in nonprofits versus academia. And part of that may be because of the different cultures of nonprofit world versus academia. One might be more attractive than the other to students these days. But I think that there are just more opportunities than were available, even 10 years ago to continue work in pollinator conservation through various nonprofits.
Yeah, so I couldn't really say much from the university side of things, besides from what I've heard about people complaining about their PhD programs. But I would say as far as I see a lot of interest and a lot of enthusiasm, but I'm not really sure how it goes to being supported financially. For myself, I had to basically launch my own product lines, and people bought those, and that's how I funded myself. But yeah, I see the enthusiasm there, definitely. But as far as how that turns into career goals or anything, I'm not really familiar in that side of things.
And how do you see the young scientists and researchers changing the field? Not necessarily in pollinator, but maybe general in science, in biology.
One thing I've noticed is, especially when I was starting out, when I was looking for experts in the field, a lot of them were sort of aging out or had passed away. So there wasn't really anyone to talk to about certain things besides just looking at the keys. But I'm starting to see a lot of younger people just get really, really invested, and they're starting to fill in those gaps. Clearly there's information that they're still learning, but I feel like just the fact that there's so many people getting interested, it makes me feel really positive about the future for pollinator conservation, ecological conservation, just period.
I think there's also a lot of cool, like just outreach and knowledge sharing with the general public through various forms of social media. Certainly in ways that are much better than I could do it.
I think when I was trained, so my 55th birthday was yesterday, so just giving a sense of, I was trained in the 90s, that I was taught that you were to be like strictly a scientist, no like public or political opinion whatsoever, because that's going to make people view your science with skepticism if you have an opinion. But what I see in the young people in my lab today is that they're very socially and politically active, and they blend their science with their value system. And they have taught me a lot about broadening access and broadening perspectives, and then also the importance of getting involved with things that you believe in. And so for me, they truly help to fight against the cynicism and pessimism that I am prone to having, because they're incredibly courageous and clear in their commitment to science, but also their commitment to these social justice values that are important to them. And being able to see them also kind of like slip between, their science and then science activism, if you will, and to do so seamlessly, when I was specifically taught that if you do that, it'll ruin your career. It's been really encouraging for me to see, and gives me a lot of hope for the future with what all of these bright young scientists are bringing to the table.
And I think that sort of overall, building on what Gail was saying, that there's more of an acceptance of different types of careers after you get your degree, which is great.
Yes, one of the things, just following up on that, is that there's more and more PhD students, and not just students, people with PhDs, which is not necessarily a bad thing, but at the same time, at least in my part of the continent and world, the reason for that is because there are open options for PhDs, and if there will be more work in industry, different types of NGO, etc., people will maybe go necessarily there before they would choose a PhD. One question that regarding the gap between research and application of what we discovered, I can see a big gap in Europe. I like to use this example, although it's a little bit of a random example. There was this research paper where they tested if they would paint a cow with the same stripes as a zebra, would the flies bite it less? And they showed that it does, but nobody's really painting their cows right now, although we have shown that the cows will be happier, produce more milk, and etc. So do you see that gap between discoveries and application of discoveries in your country?
Oh, I 100% see that. For one example, it's language, because I've started to realize that it takes a lot of time and effort to actually write down what you've discovered and just basically get it peer reviewed. So a lot of things that are pretty commonly known, I've realized that they're just not written down. For example, like a ecological niche versus a niche ecosystem. Those are terms that I use pretty regularly, but outside of a certain group of people, like a niche ecosystem, people are like, what is that? Or why are these things happening? But yeah, I feel like the gap in taking the time to write things, because there's even discoveries I've made, I haven't written any of the papers for them just because it takes so much time. I need to get on. But yeah, I think that's happening a lot.
I've seen change in almost real time based upon our research. And I'm not saying like we changed this, but we do, like I said, I work in garden systems and study a lot of native plant pollinator interactions. And in the beginning, when I would give these talks, some of the gardeners would come up and say, oh, honey, that's all well and good, but those plants are ugly and nobody wants them in their yard. And then I do a lot of research in people's gardens, and there was one gardener's garden that had been featured in Fine Gardening magazine. So like a really beautiful garden that had received like national media attention for its landscape design and beauty. And I went back the second year that we were studying their garden, and they had a bay of Douglas's aster and goldenrod, which gardeners tell me all the time they hate those plants because they grow beyond boundaries. But here was like a bank of them in a garden that had been featured in Fine Gardening magazine 1 year after we shared the bee species list that we found on each of those flowers. So in some ways, we're able to change the dial very quickly in terms of planting habits. But I'll tell you that with gardeners, at least my sticky issue has been pesticide use, that I can have gardeners promise me that they would never use a pesticide in their garden, but I can see the sprayers, I can see the pesticides in their yard. Or they'll casually mention like, oh, I would never use pesticides. And then like 2 minutes later say like, oh, that tree had a ton of aphids on it, but imidacloprid took care of it. So like for me, that's like a social question. Like, why are people so adamantly against pesticides, but not able to even recognize when they're using them in their own yard? It's been hard to move the needle on pesticide use, but easier to move the needle on plant selection.
So something that we have here that I don't know if any other countries in the world have is extension research positions in the Cooperative Extension Service. And so these are at certain universities, there will be some faculty members who part of their job is so extension is basically all about converting knowledge into action. And so you have some faculty who do both research and work extensively with farmers, typically like a specific crop or group of crops. And then every county has some county extension agents who work on the ground with farmers, and part of their role sometimes is like keeping up to the best of their abilities on the science relevant to sort of the types of farmers or land managers they're working with, and helping communicate some of that. And so through extension, there are routes for getting information to farmers. But it's, it's not going to be all the researchers. These people don't have time to keep up with everything. But at least to some extent, and it will focus on the types of questions that the farmers are most interested in. And those folks who have extension and research positions, often what they're studying is driven by what the farmers, what the big questions and challenges the farmers are facing. That's, I guess, a pretty cool system we have here.
Yeah, I don't believe we have that in Europe. Well, I can't really speak for entire Europe. For my country, definitely, there's not any really link between the discovery and the application of that discovery. So here's one question that we ask on each of the panel today, and it's also a question that we started asking on one of the events before, and all of the panelists love this question. So if you could design one dream research project with no funding limit at all, what would it be?
So there's one that I'm actually working on already, but no funding would be great for this. So there's a scanner called a 3D scanner. It's used for scanning bees from all angles, and I'm updating it to scan quicker and scan live bees, and basically using their behavior. So I'm starting with male bees because they're easiest because they sleep out at night on different plants. But I would love to get this going faster to be able to speed up the scan time, get more images, and get it out into the world. And then I think it would be amazing to develop this into something that people can use instead of collecting, because I love seeing the bees like visiting areas and it's generations later. And like, oh, maybe that bee I photographed this year, these are their descendants. I think that would be so cool, and I would love it if other universities also got into that as well.
I would love to study nesting habitat of bees more. Similar to what Eleanor has discovered about increased sand, you have more bees. I'm really interested in how bees are using fragmented urban patches of habitat for nest site. I would love to be able to, and I don't know if this is possible at all, I would love to be able to use an approach like Walter Schinkel did with ant nest, where he would pour molten metal or like plaster into like ant nest and then excavate them so that he could see the number of like feeding chambers and brood chambers and just like the architecture of an ant nest. I would love to be able to do that for urban bees and see how within garden and landscape level resources influence ground nesting bee architecture, and be able to relate that to reproductive success and output. I would ultimately love to be able to do that without killing any of the bees. I know that pouring the molten metal in would kill them all, but I'm just really interested in understanding what's going on beneath the soil surface. I know that some people have started using computer vision and cameras to do that for bumblebee nest. I want to do that for like all types of soil nesting bee nest in urban areas, and being able to relate that to landscape fragmentation and quality green spaces, forage, all of that stuff.
Oh, by the way, Gail, we should talk more because I've actually started raising ground nesting bees.
Oh my God, Crystal, yes, let's absolutely follow up.
Yeah. Cool.
So what would be really exciting for me at the moment, sort of an expansion of what I'm currently doing. I'm really interested in how a specific type of management or specific landscape context affects multiple ecosystem services simultaneously. And so for example, in my ranching system, I've currently been focusing on the native plants and the pollinators, but asking at the same time what's happening with collaborators, of course. What's happening to the soil microbes? How does this affect the amount and quality of forage, which is what the ranchers care about? Maybe impacts on some of our herbivore insects. And so taking a big systems approach and figuring out how, sort of one type of management change affects the whole system, water quality, erosion, etc. Which of course requires a lot of collaborators to do and a lot of funding for all the graduate students. But it would be very exciting to me. Yeah, and I'd love to know what the bees are doing below ground and even where they are. So we're out in these grasslands for, so our field season, it gets very dry in the summer here. So our field season is about a month long, and then it gets too dry and hot and there aren't many flowers. But we're out there walking around in these grasslands like all day, every day, and we see very few nests, also very few snakes, surprisingly. But yeah. Yeah.
I love all of your ideas. Yeah, the prevalent idea for European panel was that they want more funding, obviously, and they want research projects that would last for multiple years. So basically just a longer monitoring schemes that would provide much clearer data. and incorporate that with the weather stations and just the general environmental data. But yeah,
so if I can build off of that, something that's like not my dream research project, but something where there's a big challenge for the US that I think the USB community as a whole would love would be a nationwide bee monitoring scheme. It's doing so is very challenging, and we'd love to be able to have something like that. So we have, like I was saying before, there are like specific parts of the country where there's a university or someone has their specific field sites that get sampled, and then most of the country gets very little sampling. So even with just the few years that I've been working here in Texas, that we're finding we're going to greatly increase the length of the species list for the counties we're working in, just because nobody's been looking. We found this one bee species at multiple sites. It had last been reported for Texas in 1905. So there are a lot of parts of the country where it would be really great to have just even monitoring going on.
Interesting. And we are nearing the end of this panel. So one final question is, what message would you share with young scientists passionate about protecting pollinators?
I guess I always just start out by telling people that nature doesn't have to be a place you travel to. It could be in your own backyard. And that if you want to save the pollinators, it's not just picking that specific species or specific animal. It's about saving the entire ecosystem and understanding the importance of everything in it, even the things that we might not necessarily like weeds or aphids, ants, thrips, wasps, things like that as well. They're all important.
So I think similar motivation as Crystal, but a different aspect of that is, and I make all my students go through this process, that you want to think about your research not just as, oh, how am I going to conserve pollinators, or how does this specific thing affect pollinators, but take some time when you're starting to get into the research and to develop your project to think about what are the ecological processes that are underlying whatever, or might be underlying whatever it is you're looking at. What are the ecological or other sort of basic science questions that you're getting at while you're looking at pollinator conservation? And I think that makes for a stronger study design, also more interesting papers to read when they're addressing the basic ecology as well as the applied together. And have fun while you're doing it.
Davor, first I want to thank you for putting this day together and including us in this day. It was a monumental task of global proportion, and you really should be commended for the great work that you're doing. So thank you and all involved in your team. So I think young scientists passionate about conservation research, I would encourage folks to gain skills in emerging tools, whether that's data science, AI, it's kind of unavoidable, molecular techniques, but don't leave the natural history skills behind. Like, I am at a university where Jensen Huang of NVIDIA is a graduate of Oregon State. So we have like this AI data center and everything's like AI, like at our university with NVIDIA's support. And I see this like rush towards these technical tools, which I have found intriguing for what they can do. But I'm also think it's important to know the power of observation. Like Crystal mentioned, her retiree friend, that simple commitment to observing and understanding your system from a human perspective is going to pay dividends, huge dividends in terms of discovery and even just construction of good experimental design. So I think of the balance between those two, like understanding and mastering, or getting increased training in emerging tools, but not losing sight of the natural history approach, and also the importance of the power of observation is what I would encourage folks to do. And I think for folks that are passionate about pollinator conservation, they don't want to sit in a computing center all day looking at spreadsheets anyway. If that's what you're doing, make time to get out there and explore the natural world and just observe what's going on.
Thank you so much for the kind words and for the motivational words of all of you. And thank you again for being part of this event, part of this panel, and allowing us to get your perspective from your continent and your knowledge and your ideas. So thank you so much. And thank you to all of the members who stayed till the last event. We started strong in the morning, and then as the day passed on, we were less and less, but yeah, thank you all, and I had a lovely time for this event, for every panel, especially this one. So yeah, thank you so much for joining us, and hopefully we will collaborate in the future as well.
Thank you.
Thank you so much.
I know.